Welcome everyone to our AWS Certified Solution Architect 2022 course. My name is Michael Gibbs and I'll be your instructor throughout this session. I've been working now in tech for well over 25 years. I've been an architect for over 25 years now, and I want to help you get cloud hired. That's everything we do. We get cloud hired. We have a lot of free things that we're going to talk about at the beginning of this course to not only make sure you can easily pass the AWS Solution Architect certification, but you'll be prepared and better prepared for knowing how the technology works, how to apply the technology, and to some degree what's going on under the hood. And this is an AWS full course tutorial. And the reason we do free AWS certification training is as follows. We saw the courses that were out there. They were purely the name of a service and how to configure that service. But the problem is, solution architects and cloud architects don't configure anything. It's all about designing, and you can't design what you don't understand. So we're going to make sure you understand things very, very well. And that's why we do this free AWS course, to build your cloud architect career. We'll talk about, I'm sure it'll come up, some AWS career tips. This will prepare you for the AWS SACO3 exam, the brand new exam. We've fully updated it to take care of all the things in the new course. And this is an AWS Cloud Computing full course and a Cloud Computing complete course as it relates to the AWS Certified Solution Architect Associate. We want to make sure that all of you get cloud hired. I've got a student in my Cloud Architect Career Development Program that gets hired basically every single day. And my favorite thing in the world is when someone gets cloud hired. I want to help anyone in the entire world that wants to get a cloud architect job or a solution architect job, get cloud hired. Anybody that wants to earn more in tech, I want to help them do it. And I'm here to help you all get cloud hired. Give me a hashtag AWS Cloud. And then let me tell you about all the really great free things we're going to be doing along with this boot camp to make sure you can easily get cloud certified, because the AWS Certified Solution Architect Associate should be very basic and easy after this course. But I also want you to learn. My team has completely updated, and we'll tell you more about it next week, but you can be the early adopter for it right now. Our AWS Certified Solution Architect Associate and Professional Exam Guide. We've had about 100 authors to put this book together with hundreds of years of total technology experience, and I want you all getting cloud hired, and that's why we're doing this. So please give me that AWS Cloud hashtag. Now, so we can focus on making sure you understand the technology. What is the technology? How does it work? How does it benefit the customer? Because you're going to need that on a cloud architect interview or a cloud engineer interview. They're not going to ask you to go configure something or the steps, but what they will ask you is how the tech works and how to apply it. And I want to make sure that you're prepared for solution architect interviews and cloud architect interviews. So here's what I want you to do. Download the completely free or sign up for the completely free AWS lab demos. The link is in the description below. And in the description below, you can download those free lab demos. And that way you can do hands-on practice. I'm going to be focusing my time with you on making sure you understand the tech. Because I taught an 8-year-old how to configure an EC2 instance in less than 3 minutes. Taught that same 8-year-old how to do an S3 bucket in less than 5 minutes. And nobody's going to hire you just for those skills. They're going to want to know that you have it in your head. You understand what the solutions are and how they can impact business. So we're going to have a lot of fun. So please download the free lab demo videos. Sign up for them and do that on your own time. Now, this Thursday, we're going to have a completely free webinar on how to get your first cloud architect job. And in that, I will tell you everything you need to know to get hired. And while we're at it, we've got a lot of free things coming up very, very, very soon. So many things. We've got executives coming from NVIDIA to talk to you about what they want and from hiring people. We'll always have more solution architects come and talk to you. I interview CEOs constantly on what they want as part of digital transformation. So, sign up to our email list so you can find it. Now, if you can all give me a hashtag AWS Certified Solution Architect Associate, we're going to begin the class. We're going to have lots of fun. Now, I would never, ever, ever give you a class which is PowerPoint, blah, blah, blah in the background. We would never do it. We're going to have live training for 20 minutes. Then after that, you know what we're going to do? Answer your questions. Why? Because I want to make sure that you're skilled. You've got knowledge and capabilities so you can have the absolute best cloud computing career in the world. We will cover all the recent updates in the Certified Solution Architect Associate. We will also include much of the AWS Certified Solution Architect Professional in the same boot camp because the Associate's just not enough. And I want you to have much more competency and much more knowledge. And that's why I'm focused on having you download or at least sign up for the free labs, which you can do on your own, and making this a real classroom that you can actually learn. I used to take these courses constantly. They were for $3,000 to $5,000 for the week for the ability to ask questions. And that's why I'm doing it completely free, because I know most people can't afford the kind of training they need. And I don't want them getting something off of Udemy, which is taught by somebody that's never done the job before. I've done it for 25 years, and I want to help all of you to get cloud hired. So that's why we're going to cover this week. We're going to start by having a lot of fun. So this week, we're going to be covering the AWS Certified Solution Architect Associate. This is a free AWS course to help with your cloud architect career. We'll cover AWS career tips and cloud architect training, which is different than Certified Solution Architect Associate training. But, we're here at Go Cloud Architects and Go Cloud Careers to help you get cloud hired. So we'll begin. We'll speak for approximately 20 minutes. And then after, we'll answer questions for approximately 20 minutes. Just to let you guys know, it costs about as much as a new car to produce one of these things. By the time we take into account all of the team members that we have and all the work they're doing, and we're going to do it for you to make sure you get hired. So if you think anybody needs help, guess what? Send them a tweet, make a LinkedIn post, and invite them to this free training. While we're at it, please subscribe and hit the bell to our channel, because you're going to hear a lot about new things. Like tonight, we're going to talk about how to optimize and get hired for cloud architects versus how to get hired and optimize your career for cloud engineers, because the careers are so different. Most people confuse them, and that's why they can't get hired. So we're going to be talking about that tonight to help you build the best cloud computing career. But let's begin. We're going to begin with the AWS cloud and how it is organized. So to begin, let's talk about the AWS cloud organization. The first thing we're going to talk about is the AWS region. Now, what is the AWS region? Think of a massive geographic area, like a continent or part of a continent. So this big global area, that's what a region is. And then we're going to be talking about availability zones. And guess what they are? Nothing more than a simple data center. So you're going to have a big, giant geographic area. And inside of these big, giant geographic areas, what are you going to have? Data centers. In the data centers, you're going to have servers and storage, physical load balancers. You're going to have firewalls, routers, and switches. Guess what? The same thing that you have in every other data center. Now, what the cloud is really? It's just renting space in somebody else's network in a data center. It's all been virtualized for you. It's nothing more than that. That's why all clouds are the same. Now, when we teach this course, we're going to try in many cases to teach the generic technology. So you know how to work with AWS, Azure, Google, Alibaba. It doesn't matter. If you understand the cloud, you understand all of them. We'll also talk about local zones, and we'll show how that can reduce latency and improve performance. And I'll show you exactly what that looks like. And we'll talk about edge locations as it pertains to the AWS Content Delivery Network called CloudFront. So let's visually look at this for a minute. Here, what you can see is the AWS cloud and how it's organized. You can see this big, beautiful green box, which was drawn by my team, how that represents, a geography, like a whole continent or part of a continent. Now, the next thing we'll actually talk about is those availability zones. And you can see in this diagram, what do we have? We have these availability zones that are connected to each other with links. What do you think those links are? Network links, most likely fiber optic links, multiple fiber optic links, 10 gig links, 100 gig links, and link aggregation groups, or port channel, ether channel, whatever terms you want to call it. Same kind of concept where we're bundling multiple links together. These links are going to be in a highly redundant manner, and there's going to be some routing in between the availability zones. And of course, routing between regions as well. So now you can see region, large geographic area, data center availability zone. What's a data center? Again, it's just it's a room full of routers and switches and servers and storage and load balancers and firewalls, etc. So now while we're at it, let's talk about the concept of local zones and what it is. Now, when you want the most high performance in the world, you can't use the cloud. I'm going to say this again. If you're looking for ultimate peak performance, you can't use the cloud. See, in the data center, we can do many more things on the network. We can actually lock down our networks and make them more secure if we need to. But, keep this in the back of your mind. The data center will always perform better. Why? Because the storage we have in our data center is going to be far faster than block storage, because there's the latency on the wire to take you to the cloud provider. So imagine that you have a direct connection or a private line to the cloud. Basically, it's kind of like a wire, just sort of like my iPhone cables here. Now, what happens is it takes time to transmit your information over the wire, and we're talking about milliseconds. Now, that's okay, right, for normal things? Yes, it is. But there are applications where a nanosecond can be of competitive business advantage. And when you deal with that, for example, a nanosecond being a competitive advantage, it makes things on the cloud being impractical. So that's why they're coming up with local zones, which are still never going to be as fast as your own data center, but it's a midpoint, and I'll show you why. A local zone is an extension of the region. So you can run latency-sensitive applications closer to you, the user. It enables you to put your computing power closer to the users. What'll happen is you first have to opt into local zones. Then you're going to create a subnet in the local zone. And then, of course, in your subnet, that's where you're going to place your systems. Your virtual machines, otherwise known as EC2 instances, your load balancers. You could be putting your containers like Elastic Kubernetes service or any kind of container orchestration you put there, the Elastic Container Service, Kubernetes service. We'll talk about why you probably don't want to use the Elastic Container Service as we go through this, and why the Kubernetes environment is much better, but you can still use both. Now, there are some local zones that are going to offer even more resources to you, like Elastic MapReduce if you're trying to do some mapping and reduction to create a data lake, for example, or change information between databases. Elastic Cache, which is some basic caching, which we could talk about. Of course, you could build your own Redis cache and not use it, period. RDS systems and even dedicated hosts. So that's what we're really, really talking about. So what's it look like architecturally? I'm going to show you this, and I'm going to draw it out for you to make sure it makes more sense. Local zones are realistically this way. Again, we've got this giant green box, this large geographic region. And in this region, that's where the majority of our systems are going to be. We're going to have little data centers. Now, these local zones are effectively data centers in between your data centers. So I'm going to do this. I'm going to map it out with you real time so you truly understand this. Sometimes I just love using a whiteboard. So let's look at it this way so you can understand it. In a traditional environment, you're in your data center, and everything works great in the data center. But if you wanted to use a cloud, and the cloud is nothing more than somebody else's data center, we call this the AWS cloud. It could be any cloud for that matter. What happens, as I mentioned before, is you've got this latency over your networking link. And that latency could be too much for the business application. So what a local zone really is a mini AWS data center between you and the cloud. We'll call it AWS local zone. Oops. It's a mini data center. Actually, it's not that many. And what happens is we call local zone is we can put our latency sensitive things in between our data center and the local zone. And then, of course, the local zone and all these other things will basically have communications which will be backhauled back into the cloud. And in this manner, you can actually put your low latency things closer to you. Of course, if you're looking for the ultimate in availability and the ultimate in performance, we can get rid of all this edge location stuff and just keep our critical applications in the data center and latency sensitive and critical applications in the data center, and then use the cloud. or we could take advantage of a local zone. There's benefits and detractors to do each. That's the kind of thing we could cover in our Cloud Architect Career Development Program, but there's lots of reasons to know how and when and where to design systems. But this week we're focusing on certifications. So that's what a local zone is. Now let's talk about an edge location. The edge locations are for the CloudFront Content Delivery Network. And realistically speaking, edge locations are basically going to provide user access into the Content Delivery Network. Now we will go into depth into CloudFront, and we will talk more about content delivery networks when the time progresses, but because right now we're talking about the AWS cloud and how it's organized, we talked about regions being a large geography, data centers being called availability zones, the data center between you and the cloud provider being called the local zone, and it's just another data center, nothing else, nothing fancy. Now let's talk about these edge locations. So many of you, when you go to the internet, let's say you wanted to go to www.gocloudcareers.com, what would happen is your computer would then do a DNS lookup to see who has the IP address of www.gocloudcareers.com. Then what would happen is the DNS server would give you the IP address. Then your system would look in its routing table, it would find its default router, and it would do an ARP who has the MAC address for www.gocloudcareers.com. And then the packet would be sent to the upstream router. Now, without a content delivery network, if you're in Athens, Greece, where I'm from, for example, or you're in Alexandria, Virginia, or if you're in Cambodia, Cameroon, or Chicago, basically you would have to be accessing the network over the internet coming back to my website. The problem is as follows. There's latency going from point A to point B. And the latency may kill your user's experience. So a content delivery network, and I'm going to show you how this works in a minute, is going to make your content closer to the users so the users have a better experience. Now, edge locations are where AWS puts its content caching and its private network, and I'll show you exactly what that looks like. It's really, for those of you that are new to cloud but have worked in networking, it's essentially called the point of presence, where lots of people do their BGP peering and they connect to each other. For example, edge locations will increase performance and reduce latency. And key, it's not just related to traffic going across the internet and using caching. It's by using a private network, and I'll show you how. And let's look at what this actually is going to look like. First, I'll show you architecturally, and then I'm going to show you the user experience. Architecturally, here's what the AWS cloud edge locations actually look like. Now, when we're here, you can see that we've got this large region. You can see the data centers or availability zones in this region. And then you can see these edge locations. This is where your content is cached. Now, let's take it for an example of reality in real life. What's it going to look like and how does this work? Let's say we have the nice, happy blue user, the one in the upper right-hand corner of the screen. Now, this user is my wife, and she's there, and she wants to go to www.gocloudcareers.com. So what does she do? She goes and types that into her browser. Now, what will ultimately happen here is as follows. If no one that day has requested information from www.gocloudcareers.com, the blue user will hit that edge location. The edge location won't have any information. The edge location would then send that information to the regional cache, which has no information. And then the traffic would be sent to the AWS source. And whether it's a static website, static files, which are an object storage like AWS S3, or a dynamic website, which has got things that are going on our virtual machines, otherwise known as our EC2 instances, that what'll happen is the user will go to the edge location. The edge location will take them right off the public internet and onto the very fast AWS private network. The source will answer. It'll hit the regional cache, the information will be stored. It'll hit the edge location, the information is going to be stored. And there you go. You've got your user. Now the next, let's say I go to the same place right after my wife went to GoCloud Careers. And now I represent the second blue user in the upper right-hand corner. Now I type www.gocloudcareers.com into my browser. My request gets sent to the edge location. The edge location sends it immediately back to me. It's cached. And by doing this, we've got a lot of benefits. And here's the reason why. First, the web servers don't have to keep answering the request. I gotcha, I gotcha, I gotcha. So we've reduced load on the web servers. Now next, let's think about this. The web server's load is reduced, but the latency is reduced because the content is already there. Now we'll talk about later how content delivery networks can really reduce costs, and content delivery networks can work very, very, very well to protect against DDoS attacks or distributed denial of service attacks. And when we talk about CloudFront and preventing DDoS, we'll talk about exactly why content delivery networks are good. Although generally speaking, you should use more than one content delivery network, just like you should use more than one cloud. We'll talk much more about that later. So now, actually, let's talk about the VPC and what it is. So when you deal with AWS, you're going to be dealing with something called a virtual private cloud. Now, I've built lots of private clouds. Every student in our Cloud Architect Career Development Program builds a cloud from scratch. You can't be a cloud architect if you don't know how the cloud is designed. So all of my students build a cloud. Now, what is a virtual cloud? So basically, here's what you need to understand. You need to understand that the cloud is just a data center and a network, and it's nothing more there. Nothing more than a network and data center. The virtual private cloud is they sell you virtual access to the data center. Kind of like if you checked into a hotel, you can consider the hotel to be the data center. In each room, you could look at it as your VPC or your virtual private cloud. It's your space in a public environment. Now, your space is safe and secure inside of this public environment, but you have to understand it's just your space. So let's talk about what that means. Let's actually look at it architecturally so you can see it. Sometimes visual images are helpful. Here we go in this environment. We've got the AWS cloud, which is nothing more than a bunch of data centers, okay? That's it, that are networked together. And inside of these data centers, you carve out your private space. For example, we've got VPC1, which is blue. We've got VPC2, which is green. VPC3, which is red. And VPC4, which is yellow. All isolated from each other, all on the same cloud. And there's lots of reasons why cloud computing can be beneficial. And we'll be talking about them throughout the week when we go into auto scaling and other things that makes the cloud more agile, which makes it potentially able to perform some wonderful digital transformation. Now we're going to talk about some basic cloud architectures. We're going to talk about a hybrid cloud. Then we'll talk about a pure cloud. Then we'll talk about multi-cloud and their strengths and weaknesses for every one of these things. Let's first begin with the hybrid cloud. If you want the best performance and the highest availability, you're interested in a hybrid cloud. What is a hybrid cloud? A hybrid cloud is when an organization keeps its data center and they connect that data center to the cloud. Now, most of the time in a hybrid cloud environment, we install like an IBM OpenStack or a Nutanix cloud on these private data centers, and we get our own beautiful high-performance agile cloud, and then we can still connect to the public cloud. We can connect to the public cloud for scalability as needed, and we can use the public cloud for what it's good for, agility, auto scaling, and all these other wonderful things. But we still have ours. This way, when the next time a cloud provider has a power failure, not that power failures can really take out a cloud, or somebody makes a BGP misconfiguration, or the next time a cloud is hacked, trust me, we've had plenty of cloud hacking in the last few years. Some customers have been honest, some cloud providers have been honest about it. Other ones have had outages that are unexplainable. Who knows? But the point is cloud provider can go down, hybrid cloud can stay up, and you're still in business. So let's talk about when that's valuable. Well, imagine you've got a hospital. If you only stick them on one cloud and the cloud went down because of a security event, a network event, or a control plane failure, then you're still up. And imagine a hospital where they're all in one cloud. Cloud goes down, patients die. So that's why we need to be very good and mindful of our architectures, Hybrid clouds, I love them. Hybrid clouds can enable the low latency, ultra performance in the data center and can allow you to scale to 1, 2, or 3 more clouds. And by doing so, wow, you're in a beautiful position. So a hybrid cloud is ideal for an organization that's got a current data center that's being well run with modern equipment. Or want somebody that needs ultra performance or ultra high availability, like a hospital or a bank. Architecturally, what's a hybrid cloud look like? It looks just like this. I'm a huge fan of hybrid clouds. I've been helping many people with hybrid clouds for as long as I can remember. And realistically speaking, the organization's got their data center, they've got a private line or some connection to the cloud, and then they use multiple availability zones in the cloud. And that way, cloud goes down, no big deal. Data center goes down, you still have the cloud. Lots of survivability, potentially huge improvements in cost performance, especially for applications that are running 24 hours a day, 7 days a week under high load. They may be cheaper in the data center, where other applications may be much cheaper in the cloud, and that's why the architects need to look at the business requirements as opposed to what's taught in the certification. So let's talk about the next kind of cloud architecture. And this is a pure cloud environment. Now, here's the thing with the cloud. You don't have to buy anything except for your routers. And in some cases, that's a great thing. Now, it may be more expensive to be on the cloud, but it may be cheaper. Again, it depends exactly on the use cases. But let's say it's a brand new organization and they don't have the capital resources to build their own data center. They can go straight to a cloud. They can build their startup things. The cloud will give them scalability, rapid deployment, enable them to connect to partner organizations, and create a really distributed environment. And guess what? I love that. But once the availability needs come better, once the business gets bigger, what do they need? Multi-clouds or a hybrid cloud. Because a single cloud has a single point of failure, no matter how many availability zones and regions you use. And we've seen this with every cloud provider that's had a major outage. But here's what a pure single cloud environment would look like. We never recommend a single cloud except for small businesses where availability is not critical. But we never recommend something like this for a bank or healthcare organization. So let's look at this. We've got, in this environment, our organization. We've got our connectivity to the cloud. And with that, we can show that our data centers are up and running. And that's how we do this. And I'm going to stop there and take some questions, and then we'll talk about connections to the cloud. We'll get into some basic networking. We'll have lots and lots of fun, but I'm sure there's questions. And, the first one I'm going to address, Chris, before anything is the JMC Global Networking Lab. And the reason I want to address this is we can't just have architects and engineers just doing labs at random. And here's the reason why. 99% of the problems we see with people getting hired is they just start doing labs, but they don't know which labs to do. And in most cases, they're ultimately irrelevant to what the employer is looking at. So I don't ever recommend finding people and just saying, hey, let's build stuff together. What is the goal of the job that you want? What are the real critical skills of the job that you need? And what projects will show the hiring managers that you're capable and ready versus just doing things. For example, architects, there's no point in them playing with Linux or doing Terraform or dealing with Python coding. That's not architect work, that's engineering job. Likewise, engineers need some very specific labs, and many of them are off of the AWS cloud. They have to be done with Linux, they have to be done with Kubernetes, they need to be done with infrastructure as code tools. So let's be very clear that we can't just do stuff, because stuff won't get you to your goal. It has to be the right stuff. So make sure if you're going to do some labs with people, make sure that you've got someone that's a senior leader in their field guiding you on which labs to do. Because otherwise, I will tell you, most of what we do is taking people that have spent years of time learning the wrong things and then retraining them. I want you all getting cloud hired. So find a good leader that can help you with that. Chris, let's go to the questions.
Okay, so how long do you want to do questions for, Mike?
10 to 15 minutes.
Okay, and we're only going to be doing questions related to the content being covered, correct?
Yes.
And
Any questions related to careers, we're going to do tomorrow morning and also tonight. And our engineer versus architect, what do you need to know to be great at your job?
All right. And if there's a question related to content that hasn't been covered yet, we will address it later.
When the content's covered, yes.
Okay.
How is scalability handled for small businesses? Prabhan, we need to know far, 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 far more to actually answer that question. I mean, it could just be something simple as auto scaling groups and object storage, or it might need to be something that would take a week and a half to answer your question based upon the actual business requirements. So Prabhan, it's all about determining what the business requirements are and then determining what you need in terms of scalability. But you haven't given me any business requirements. And without business requirements, there's nothing else for us to design. Question 2, if you have 2 cloud providers and one is and the other is recovery, is that considered a hybrid cloud? No, that's considered a multi-cloud environment. Hybrid cloud is when you have your own data center. Let's go to the next one, Chris. Isn't hybrid a mix of on-prem and cloud? Absolutely. Exactly. Will this upload it? Yes, we're going to keep this on YouTube to help as many people as possible. Please tell a friend. Is the CDN the same as an edge location? No. The edge location is where the CDN servers and network starting. What about CloudFront? As I mentioned when we covered this initially, that we'll be spending several hours covering CloudFront when we get to the CloudFront section. Go to the next one, Chris. Elizabeth James, if you have 2 cloud providers, how do you route traffic to those 2 providers? What do you need as far as networking? Well, it depends from where. If it's a web app that's being shared, you could use DNS, for example. If you want to load share between your data center to multiple cloud providers, that's going to be done via BGP. So it's about what do you need to accomplish and where do you need to accomplish it. There'll be lots of ways you're going to be load sharing and traffic engineering. Chris, we go to the next one. You understand the differences between hybrid cloud and pure cloud, but could you point out and explain the differences between high-prem, hybrid, and pure diagram? Yeah, in one we actually had a data center connecting to the cloud, and the other we didn't have any data center connecting to the cloud. Let's go to the next one, Chris. How did you get access to the class tonight? Tonight's class is the Head in the Cloud show. Chris, can you pop a link to the Head in the Cloud show so everybody can come? We'll talk deeply about why certification is not enough for cloud architects and cloud engineers. We'll talk about all the critical skills that cloud engineers need to get their first job and cloud architects need to get to their next cloud. Yes, there's going to be another live session tonight. Can I elaborate on CDN? Yes, Charles, as I mentioned actually twice when we went through the content, we're going to be spending hours on the content delivery networks when we get to that section of the course. So please stay tuned, make sure you're subscribed, hit the bell. And that way, when we get to that part of the course, we'll be covering it. And of God, hello, Mr. Gibbs. Your question is, how do I stay looking so fresh, young, and energetic, knowledgeable, and full of energy? Thank you for your time, sir. You know, hand of God, I live on the strict paleo diet. I literally do Ashtanga yoga every day, which has been modified after my injury. And I spend 90 minutes in 160 degree sauna every day to try and stretch out and control my injuries. What's the difference between an edge location and a local zone? As I mentioned, they were very different. The edge location is where you access the content delivery network, and the local zone is where you actually put something between you. In this example, I actually whiteboarded out a local zone where you've got your data center, And on the way to the cloud, you connect to another data center that's owned by AWS that's closer to you, called a local zone, to reduce latency between your organization and the cloud provider. By comparison, an edge location is where your user actually attaches to the content delivery network on the way to web servers. So very different concepts. And we'll cover more throughout the session. But we'll be spending a lot of time on content delivery networks because they're very critical. Thanks for sharing this wonderful insights. One question you, are there chances that these VPCs are not isolated and the privacy of mission critical information has been compromised? Megal, I want you to look at this. And listen to it this way. The cloud can never, ever be as secure as the network in the data center. And here's the reason why. In the network in the data center, you can do whatever you want. You can lock down your physical data center with Navy SEALs, snipers in the room. You can do network admission control called 802.1x. You could put quality of service on your systems. And it's only you getting hacked. When we go to the cloud, here's what happens. The cloud basically gives us our virtual data center inside of them. But if the cloud gets hacked, like what happened in the Azure case, customers' information can be stolen. So on the cloud, we have two things to worry about. We have to worry about traditional security in and of the way it is, reduced ability to do micro-segmentation like we can do in the data center, and at the same time, if the cloud provider gets hacked, and they get hacked, then potentially you could breach other customers' information. So yes, Magcall, the cloud providers are slightly less safe. Now, having said all of that, the cloud providers are still extremely safe. And in most cases, the cloud is more secure than a poorly run 20-year-old network in a data center. But an optimally run network in a data center is going to be more secure than your cloud provider. But there's a big difference between optimal and average. Great questions. In the slides, you were referring to CloudFront. What is this exactly? Rubix, as I mentioned, will be discussing CloudFront at length for several hours when we talk about CloudFront. Chris, go to the next one. The VPC is inside one availability zone or can exist in many? It's going to exist in many. Is this bootcamp architecture design focused? It sure is, Mauricio. But we're still covering the tech things that cloud engineers need to learn. What we're not focused on is junior level systems administration, which is how to use the management console. And here's why. In reality, a cloud architect's not going to be doing that anyway. And a cloud architect doesn't touch the tech. And a cloud engineer isn't going to be using the management console either. They're going to be using the command line. They're going to be using Terraform and infrastructure as code. The cloud engineer is going to be dealing with a lot of Linux. A cloud engineer, not a cloud architect, will be dealing with Python. And there's so many other skills. And for the cloud engineer, it's going to be how do I performance tune and how do I optimize, not how I do the simple configurations. That's called the cloud admin. And realistically speaking, there's no need for cloud admins anymore because one DevOps engineer can take 50 of their jobs away instantly overnight. So this bootcamp is predominantly deep cloud engineering and deep architecture focused, not sysadmin work. That's the kind of fields we try to keep people from getting in the first place. We try to get people the highest paid careers and prepare them for the highest paid things as opposed to the lowest end things.
And Mike, so there's still a lot of questions from a lot of different people about edge locations and local zones.
Okay.
So I'm just going to kind of put some of them up.
And that's fine. And I'm going to get to Dean. So I said a cloud architect doesn't need to know Linux, and he's talking about a DevOps engineer. A DevOps engineer is a different career. We cloud architects don't do DevOps. DevOps engineers don't do architecture. It's another job, and that's the confusion. That's what we'll talk about tonight. What is a cloud architect versus what is a cloud engineer? Because I'm going to tell you, after interviewing thousands of people, most people have it wrong. And I know what employers want because they tell me every day. So basically, edge locations are cache servers plus a network in which is used to access web pages. And local zones have everything to do with the service. Local zone is basically a data center, which is between you and them. So it enables you to put data center things in there like virtual machines. The edge locations is where the cache servers are, but here's the difference. It's not just the caching servers that make a difference. It's that when you're on the public internet going to a web page, the internet does not guarantee your traffic gets through. There's no guarantee on internet bandwidth, and there's no guarantee on your latency either. But when you hit that CloudFront edge location, that your data is immediately taken off the slow internet and onto the AWS private network, which they can basically control speed, use quality of service, queuing things, and all these things are kind of there. Edge location, availability zone, are all data centers. Yeah, all these things are data centers. Every one of them. Edge locations are, well, they could be owned by AWS, in which cases they might be, but an edge location, honestly, could be stuck in somebody else's point of presence, like an Equinox data center. You could put it anywhere they really want to put it. You go to the next one, Chris. Are local zones in an AWS cloud region synchronized, or are they totally independent? That's up to you and what you put in there. You know, you can put things in a local zone on 3 different clouds and synchronize them if that's your design, or they cannot be there. Next question, Chris. Between an edge and a local zone, can we choose when to use the other? Well, there's really no choosing. If you want a content delivery network to speed up your web app, you're going to use a content delivery network. Now, if by comparison, your goal is to improve the latency of your internal applications, you must use a local zone or else have your own data center. And in many cases, a hybrid cloud is much cheaper than a public cloud, especially if it's run properly. So it's dependent upon how it's actually architected. But most businesses will need to use a content delivery network, which on AWS would be an edge location. Of course, you could use a different content delivery network like Akamai with AWS, if you chose to, and not use the edge location. There's plenty of other wonderful content delivery networks out there, like Cloudflare is another great one. But you know, you're almost always going to need a content delivery network for your web apps, and you're also going to want to use local zones, or better yet, don't waste your time with local zones. Have a hybrid cloud, have better performance, higher security, and potentially lower cost depending upon the environment. One thing you would like to fully understand is the direct connect, internet gateway, and transit gateway. They're all very basic things, and I promise you we're going to cover them in depth, and you'll definitely understand them. Some we'll be covering today.
And Mike, my finger slipped. This is the one that we did right before this, correct?
Yes.
Okay.
And I can probably do 1 or 2 more, and then we got to go to the next question. I mean, the next back to the content. Is there a direct connection on-prem in a local zone? Well, if you need low latency, you must use a direct connection. Or something like software-defined networking or SASE. Meggle, a content delivery network is a private network that allows caching. You could use Cloudflare, you could use Akamai, Microsoft's got their own content delivery network, Google's got their own content delivery network, AWS has their own content delivery network, there's lots of them out there. Here's the thing, Meggle, don't use one. You always need more than one. Because if the content delivery network goes down and you're using it, you're out of luck. So you always need both. You should never have a single cloud, and you should never have a single content delivery network for any business for which availability and performance is critical. Okay, let's talk about connecting to the cloud. Connecting to the cloud.
Oh, sorry, that's the timer, Mike. You got good timing.
Timer? Okay, sounds good. So
Let's ask for a hashtag in the chat box.
Give me a hashtag.
If they're having fun, that is.
If you're having fun, give me a hashtag AWS Certified Solution Architect Associate.
I'm not the Cookie Monster. I don't know if I can spell that long of a word.
If you guys can give me a hashtag AWS Solution Architect or hashtag AWS SAA, I'll be fine with either one of them. But I prefer you spell it out. Keeps the algorithms happy. There we go. You're there. You're good. If you haven't subscribed and hit the bell, please do so. Let me see if you guys are doing so. I can tell real quick. And then let's get back to the exciting content. Make sure you subscribe and hit the bell. Now let's get back into talking about content, because we want to make sure you all get the knowledge that at some point in the future, you're all getting cloud hired. So let's talk about connecting to the cloud. If you're going to put your stuff on the cloud, you got to be able to reach it. Now, most of the stuff that we care about in business is not a website which you access over the internet. It's internal stuff. Internal stuff. What do I mean by internal stuff? HR applications, internal financial applications, and all these other critical things. Keep that in the back of your mind. So once you put your data in the cloud, you got to be able to reach it, right? Because you've got your cloud here, you've got your data center here where your users are. You don't have a link between them. Guess what? You've got nothing. Something my grandmother would call bupkis. You've got nothing. So, you want to make sure that you can actually reach it. Now, when we're dealing with connecting to the cloud, your reality is you're going to have a lot of options. You're going to have SSL-based VPNs, IPsec-based VPNs, private lines, Ethernet over MPLS, software-defined networking, and SASE. But for the purposes of the AWS Certified Solution Architect Associate and the AWS Certified Solution Architect Professional and the AWS Advanced Networking, which is an intro to networking, we're going to be talking about VPNs, and we're going to be talking about private lines. So let's first start with a virtual private network. A virtual private network is really nothing more than a means to secure private network connectivity over a public internet or a public network. Now, I've been working on VPNs and clouds for 20-some years. Most VPN technologies in today's world are either an IPsec tunnel, an L2TP tunnel. It could be an MPLS BGP VPN. It could be VPLS or virtual private LAN services. But today we're going to be talking about IPsec tunnels, which is the type of VPN you're going to be using when you're dealing with cloud computing and connecting to your cloud provider. Now, you may ask, why do I need this silly VPN thing? Why can't I just use the internet? Well, a couple of things. If you're going to use the internet, you'd have to have public addresses on all of your systems, which we know is not possible because we ran out of IPv4 addresses a long time ago, and that's why we use private addressing, which we'll talk about later. Now, next on this list is the routing. If we're going to use the public internet to do all of our routing, we need to take in, say, 800,000 routes from the internet, and then all of our own routes, and we'd have to have public addresses. So we'd be dealing with $100,000 routers as opposed to maybe $5,000 routers that could handle a big full internet routing table. Now, I'm used to doing highly complex internet routing. I'm one of the first Cisco certified internet experts, and I've designed consulted on half of the world's largest internet service providers. But let me tell you, this stuff is complicated. And, it's not something that the average bear would want to be dealing with, for example. And you stick a private line and a VPN between it, and all that complicated BGP and traffic engineering and route aggregation and all that stuff, for the most part, is simplified. Address spacing with VPNs, we can pass our private addresses across the link, and we can also pass our routing across. OSPF, BGP, whatever our routing protocols are. Now that means we need to be on the same subnet on both sides. And we can't do this over the internet. But what we can do is simply as follows. We created an IPsec tunnel Both sides are on the same subnet, and now we can pass routing information. So let's look at what your VPN would look like architecturally. Realistically speaking, you're going to have your data center, you're going to have your cloud. And while we're dealing with the data center and the cloud, what you're going to be dealing with is there's a router that connects to the internet here, the virtual gateway on the AWS side is connected to the internet, and you're going to create an IPsec tunnel. Very simple. And why is this so great? Well, the internet's everywhere, right? Meaning you're already connected to the internet, and AWS is connected to the internet, Azure is connected to the internet, Google's connected to the internet. See, they're all there. And when you realize that, the ubiquity or the internet being everywhere, it makes it just so easy to just create a connection between them. By doing so, guess what? You are now in a position, you've got a straight line connection across the internet. Want to create another connection to another site? Poof. Start your tunnel on both sides and you've got connectivity. So the internet is fast in terms of connections. But there's other things that we'll talk about, what, how, and why. If I can find my mouse here, I will move. Okay, so there is that. So let's talk about IPsec VPNs some more. IPsec VPNs get around the security and IP addressing challenges of the internet. IPsec realistically does this. Let's say my hand is a tunnel. You put your private traffic through the tunnel, and on the other side of the internet, it comes out of the tunnel, and then it's back on your private network. Because it's private, we can use our private information, pass our routing information. Now let's keep going while we're at it. IPsec will encrypt your traffic so that if anybody was able to get access to your traffic going over the internet, guess what? They can't do anything with it in any way, shape, or form. And that's why it's not going to be useful to them. But IPsec does a little more than that. It prevents a man-in-the-middle attack. What is a man-in-the-middle attack? So let's say I tried to create a VPN to Chow. Chow is one of my amazing cloud architects, and she's got an internet router at her house, and I've got an internet router in my house. If I connect to Chow using IPsec, I know that Chow is actually Chow. And what do I mean by that? Actually, I might even draw it out for you. What I mean by that is I need to authenticate the person on both sides. I also need to make sure that the message has not been changed. Early in my work life, when I used to practice internal medicine as a nurse practitioner, I used to write prescriptions. Now, if I had a person having a heart attack and I wrote for a 4 milligram prescription of morphine, that might be the appropriate dose for a patient having an active heart attack. But if somebody changed that 4 milligrams to 40 milligrams, that patient would overdose, stop breathing, and in most cases die. So we need to ensure the message integrity of what we're dealing with. Now, also, we need to be sure that the sender can't say they didn't send it afterwards, and that's called non-repudiation. So let's build the whiteboard. Let's whiteboard out a VPN right now. So over here, what we're going to do is we're going to have two people. I was mentioning Chow, but I think we'll go back to my favorite kind of examples, and we'll use some furry friends. So, because I always love furry friends. So let's say on this one side of this, we have my cat Cindy, and my cat Cindy is basically wants to talk to her friend over a VPN. So let's go find one of my cat Cindy's friends.
Mike, you are not sharing the screen.
Oh, thank you, Chow. See, that was the Chow I was referring to. Now, let's say by comparison, let's say that Cindy wants to talk to her friend who is a rabbit that found its way into my garage. And obviously, I put out food and water for the rabbit, and I got it outside of my house and found somebody to house the rabbit before my Cindy could terrorize this pure, beautiful, sweet rabbit. So let's say both of them are actually connected to the internet, and they wanted to have a conversation, maybe about carrots or about chasing rabbits or doing any of these things. Now, if they're already on the internet, here's all they really need to do. Now, first, Cindy, we're going to pretend she's a sweet, gentle thing and she doesn't eat rabbits, which is totally not true. But we're going to pretend right now that my Cindy is a pure angel because I'd like to believe she is. Now, each one of these has a router that connects on the internet. And let's say Cindy's a sweet little girl that does not eat rabbits. and the two of them want to have a conversation. Now, by having the two of them that wanted to have a conversation together, guess what? And I'm trying to find some more animals. Everything's going to be fine. Cindy's going to be talking to Bunny. Bunny's going to be talking to Cindy, and they're all good. Now, when the meeting is set up and this connection is set up between Cindy, guess what? We know that Cindy is talking to her friend Cutie Pie the rabbit, and everybody's happy. Now, without IPsec, here's what could happen. We could have this beautiful cat named Sunny, who's my Chief Operating Officer Chris's cat. Again, a wonderful cat. But let's say Sunny likes to eat rabbits. And let's say that Sunny was pretending to be Cindy, and the rabbit, Mr. Rabbit, was saying, "Hi, Sunny, my home address is here." Now, that would be a problem because then Sunny the cat would eat a beautiful rabbit, and the rabbit would not be happy. So we have to first prove that the message is real, and IPsec provides that advantage. Now, secondly, IPsec uses a hashing algorithm, meaning it creates a mathematical formula to let you know that nothing has been changed. In this way, Cutie Pie Rabbit over here can verify that Cindy, the sweet little girl that I hope she is sometimes, is actually her friend. And then when she says, "Come to my house at this address for dinner, I've got carrots for you and spinach for you," the rabbit goes to the correct address and not the address where the scary Sunny the cat lives. Now, next, we want to make sure that when we're dealing with our cats and our rabbits and they're happy, that Cindy the cat can't say to the rabbit afterwards when the rabbit came to the house, "I didn't invite you." That's called non-repudiation. So when we're dealing with IPsec, we're getting three benefits. Endpoint verification, which prevents man-in-the-middle attacks, message integrity, and something called non-repudiation. The cat can't say that I didn't invite you. So let's talk about why we love VPN so much. Because the internet's everywhere, and you can set it up in minutes, or seconds, actually, if you're good. Where when we want a private line, which we're going to talk to next, it might actually take 6, 8, 10 weeks to get your private line set up. So VPNs can be done in seconds. They're generally speaking very inexpensive, and we can create multi-point tunnels. For example, my cat Cindy could create a VPN connection to Sunny the cat and somebody else's rabbit and somebody else's cat, all through the same internet connection. It's called a point-to-multipoint connection. Beautiful, simple, and elegant. Kind of keep that in the back of your mind. Easy, easy, easy going. Now let's talk about the disadvantage of the internet. In this case, internet performance is not guaranteed. When you stick your traffic on the internet, there's no guarantee that it's going to get to the destination. Zero guarantee that it's going to get to the destination. So because of this, if you need critical performance or low latency, don't use a VPN, use a direct connection. On a direct connection, it's 2-3 hops. Although the AWS does it a funny way, it could be more than that. But on a private line, it could be 20, 30 routers or more that you're going to. And that's the key. The internet is what's called best effort. Zero guarantees of your delivery. So once it's on the internet, you don't know if it's going to get there. Private line, guaranteed latency, which is how long it's going to take to go from both sides of the wire, and guaranteed bandwidth. So when it matters, you're going to be using a direct connection. Now, an AWS VPN is typically going to be set up between the organization's data center and your VPC. It's called the site-to-site VPN. But VPNs can also be set up between multiple sites as well. The way this works is both sides are set up to terminate the VPNs. You could call it an endpoint, and each endpoint encapsulates the packets and puts them into an IPsec tunnel, which sends it to the destination in that encrypted environment, just as we described. So when these tunnels get set up, here's what happens. They have to exchange security keys. And it's called an Internet Key Exchange Security Association. What happens is each one of the routers comes up, and they determine the encryption type, like SHA-256, for example, the algorithm, etc. And of course, you can set up dynamic routing over BGP, which is preferable in most cases. Or if you don't know BGP and you don't know routing and you've only got a single point of failure and a single link, of course you could set up static routing, but I strongly wouldn't recommend that. I'd recommend learning BGP and being able to use dynamic routes, just like your VP, just like your GPS. If you're using dynamic routing, which is effectively a GPS, and I'm going to go to Chris's house, and parts of I-95 are blocked off, it'll tell me rerouting to go left, go right. A static router is like an old map book. You basically write your plans out and go left, drive 20 miles, go right, go 20 miles. But if there's a roadblock, you're in trouble. So that's why you'd want to use BGP. Now, AWS will tell you that their VPNs are highly available and redundant. And this is partially true, but partially not true. And I'll show you what I mean. Because the VPN on their end is logical, they'll say that it's fully redundant, and I'll show you how they're going to say connect the two things. That's great until the router on your end links goes, or your internet connection goes, and all of that goes out the window. So we'll talk a little bit more about that in a minute. But what happens is when you set up your VPN to AWS, which is a logical router, virtual router, as opposed to physical router, the virtual routers can't go down as long as the cloud's up. So what happens is a link is going to be connected to two availability zones, which is two data centers. And you can be set up as active-active or active-passive. For organizations that don't know routing, active-passive will be the best strategy, and that way they don't get out of order packets. For organizations that have the sophistication to understand routing, you're not going to create multiple VPNs and not use them, or multiple links and not use them. You're going to route using BGP. So let's look a little bit about why I said it's partially true and partially not true regarding the single points of failure with the AWS VPN. Now, AWS would tell you this is highly available, and they'd say, look, this device and their VPN device is not going to go down. It really won't. That's not how these systems work. But the problem is, if the device on the right side in the organization's data center goes down, everything's dead. And if the internet connection the organization is using is also down, the systems are dead. So if you really want a high availability VPN architecture, the only option you really have is as follows. You can create, and let's say this is AWS over here, and this is multiple availability zones, but we're just going to make one single box. And then this is your data center, which is sitting over here. The only intelligent way to do this is to put two routers in your data center, R1, R2, and each one of these links should be on a separate internet service provider in case the router or the internet service provider links. And then what you're going to do is connect to two virtual routers on AWS. And by doing so, you can lose, bear with me. By doing so, we can lose any of the following. We can lose one of these internet links or one of the routers. And that's truly, truly, truly how you build a high availability setup. You would basically create two routers with two connections going to both places. And now you can lose a router. One of these routers can go, for example, or one of the internet connections could go, and you're still happy, and you're still connected to the AWS cloud. Kind of keep this in the back of your mind. So let's talk a little bit more. As I said, the virtual gateway router on their end is highly available, but your stuff is not. So when it comes to high availability, one cloud is not high availability no matter how many availability zones and regions you use. Single router, no matter what, is not high availability. Military adage is 1 is none, and 2 is 1, and 3 is greater than 2. 1 is none. 2 is 1, and 3 is better than 2. Critical, critical, critical for you to understand that, and critical for our world. How do you set up a VPN? It's silly easy. Basically, you're going to determine which AWS virtual gateway you're going to connect to. Pick a routing method, static routes or dynamic routes. And either you set up your tunnel configurations, or you go to the form and AWS spits out a virtual configuration for you, and that's it. But I'll give you a little more information. You can obviously do a custom setup, which is what a network architect like me would do. I'd have my network engineers really put a nice routing policy, so that way I can tune the performance and tune my traffic engineering. But if you don't know what you're doing, well, actually, you shouldn't be touching this stuff at all because you'll just be taking systems down. But if you know what needs to be done, but don't know how to configure it, which is totally fine, the AWS System Management Console will literally create an auto configuration for most VPN devices, whether it be Cisco, Juniper Networks, Palo Alto, or Fortinet. And of course, you can monitor the status of your VPN tunnels with CloudWatch on their end, but you could also look at what's going on your routers at your end. Now, since we talked about what is a VPN, which is creating a virtual network inside of a public network, let's talk about a direct connection, which is like a wire. I've always viewed a direct connection as simply a wire between two locations. That's the way I like to look at it, because I've been working with private lines now for a couple of decades. And let me tell you, to me, it was always easier to explain it to people in terms of simple wires. So let's talk about this. A direct connection is the equivalent almost of a private line, and we're going to walk you through it. So why would you use a private line? Well, guaranteed bandwidth, consistent latency, and it's going to be the highest availability and reliability. Less to go wrong on a wire than the entire internet. Now, when you need higher performance, you can bundle links together. Now, if you have one link that's 10 gigs, you've got 10 gigs. If you've got two links that's 10 gigs, you've got 20 gigs. If you bundle 3 links together, you've got 30 gigs. And if you bundle 4 links together, it's called 40 gigs. For those of you that have been networking for a couple of decades like me, I'm sure you've heard of port channel, ether channel link aggregation groups. Link aggregation groups are effectively the new de facto standard for bundling links together. We can bundle up to 4 links per link aggregation group, and obviously we can create multiple link aggregation groups across routers. So now now that I mentioned that it's a logical wire, let's talk a little bit more about it. And you can think of this wire being a wire, but it's really not just a wire, and I'm going to get much more into it. Now, to connect to the cloud, you're going to be using a fiber optic connection, which is always going to be single mode fiber, because we're going over distances. And remember, it's going to be a 1 gig link, a 10 gig link, and finally, AWS supports 100 gig links. There are several steps along the way, and we're going to show you that in a minute. But before we show you that in a minute, let's talk about the key underlying technologies. Obviously, you need a router. You're not connecting to anything. The router will have to be a fiber optic port because you're not going to go more than 100 meters on a copper connection. So it's going to have to be fiber optic. Now, single mode fiber is the only thing, as I mentioned, that's going to get you the distance. So if you're dealing with 1 gig, it'll be 1000 base-LX. If it's 10 gigs, you're going to have 10 G base-LR. For your exams, you might expect to see 1000 base-LX or 10 G base-LR for 10 gig respectively. Now, for any of you that are coming from the networking world, which is like the perfect world for cloud computing, because we network people who've been working with cloud for 20 plus years, 25 years, you know that when you're dealing with a laser and you put those lasers in your fiber optic part, there's a send laser and a receive laser. Now, if your send laser is up, but your receive laser is down, in many cases, the link will stay up. The problem is your traffic won't be flowing and your traffic will be tossed apart, thrown away. So when you have multiple links, you need something that's going to let you know if one of those links is partially down to close that entire link, like a health check, which we'll talk about when we get to DNS, or load balancers. AWS, like most good networking organizations have done for the last 20 years, enables something called bidirectional forwarding link detection. And that means if you've got a send and receive laser and one of these lasers goes down, it removes the entire link so you can fail over to your backup connections, which is exactly what you need to use. Now, when you purchase a direct connection, which I'm going to show you about in a few minutes, you're not exactly buying a straight wire to the cloud. It's like you're buying a wire to an internet point of presence, which then you're going to backhaul you back, and I'll show you that in a minute. So you connect to your direct connection location from your service provider, and then you get backhauled back to AWS. So, and there's going to be something called the letter of authorization required, and I'm going to walk you through that right now. So here's what it really is going to look like. To the right, we've got our on-premise environment. Got a router here, ideally multiple routers. And we're going to have a wide area network link to ideally 2 direct connection locations. So let's start with the bottom link. We have our own router sitting in a direct connection location. We buy a link to that. Now, we have to connect our router or layer 3 switch to the AWS router / layer 3 switch, and we need to run what's called the cross connect. What's a cross connect? It's a wire between our router and their device. And then the traffic is taken back over the AWS network. So think of this. On-prem is our data center. We have 1 or more routers that are connecting to each direct connection location via a WAN link, like a 1 gig WAN link or a 10 gig WAN link or a 100 gig WAN link. We then connect to our router over the WAN link, just like we've been doing in networking forever. Nothing's new here. Between our router and the AWS router, we need to run a cable called a cross connect. And that cross connect gives you the permission, or your service provider the permission to run that cable between your device and the AWS device. Because you can connect to this direct connection location to your router. You have no access to AWS that way until that router is connected to the AWS network and routing is actually established between them. So you're going to need something to enable your service provider to run this little orange cable between the customer router and the DX or the designated router, the direct connection routers for the service provider. So look on the bottom right. You can see direct connection location. You can see that little orange connection between our devices and the AWS devices. And in those particular cases, that's called your cross connect. And that's done by the letter of authorization. So you must get this letter of authorization prior to being able to run this. So let's talk about this direct connection, what this letter of authorization is. That it's the ability to connect that connection between your device and their device, just that wire. To receive this letter of authorization, you need to identify the region for which case you're going to be connecting to. Now, you'll request the letter of authorization either via the management console, the API, but also you could do it over the command line interface. And if your application is complete, what'll happen is AWS will provision the switch port on their layer 3 switch, although they're going to be laying layer 2 routing to you, and they'll let you run that cross connect. Now, what at that point is you download the letter of authorization, you hand that to your service provider, and they cross the cable for you. But remember, the cross connect's just a wire between them. Now, when we're dealing with AWS, we're going to get into concepts called public and private interfaces. Now, if any of you were involved back in 1996 working on Frame Relay, like me, or 1998 working with the ATM cloud, or 2001 dealing with the VPLS cloud, well, BGP cloud, RFC 2547 cloud, or the VPLS cloud, this is no different than the same 25-year-old networking technologies. Basically, you connect to a public virtual interface, and that will enable you access to public AWS services. Public AWS services are going to have a globally routable IP address, which means public, and you'll be exchanging information, routing information with BGP. Simple, simple, simple stuff. Now, AWS will not re-advertise your routes out, and by doing so, you don't have to worry about becoming a transit ISP for the entire internet. You know, it's the same thing as setting up your routes in BGP and using the no export community so your service provider won't export your routes. Now, when you deal with AWS BGP, well, you've got some serious limitations. They won't take a lot of routes from you, basically 100, which is nothing. I connect to the internet at my house to 3 different internet service providers, and guess what? I take in 800,000 routes from each internet service provider. AWS lets you give them 100. It's nothing, nothing, nothing. So because of this, keep that in the back of your mind. So here's what I want you to understand what it's going to look like. Architecturally, I want to draw this for you. I don't want any confusion. I know many people are confused upon this, especially people who have taken others, AWS Advanced Networking courses, those that are taught by non-networking people, and they get so confused. I don't want you guys being confused. So realistically, all what's really going on is here, you've got your box over here. This is your box. So this is your data center. then connect over here to the cloud. And what's going on is when you're connecting to, let's call it the cloud's router, you're going to connect to the virtual router in the cloud. Let's call it a virtual router, VIF, virtual interface. And now through this virtual interface, you can connect to, say, S3, or you can connect to any other multiple devices. So the way this happens, let's just see, AWS public service. Now we've got two, S3 and another public service, SCRVICE. May not have spelled that right, it doesn't look right, but we're doing stuff live in real time. So basically what happens is we connect to this virtual interface, and they build virtual links, basically pseudo wires, for those of you that are familiar with MPLS pseudo wires, to all of their services. And in that manner, you're getting one connection to them, and they can basically create virtual circuits for you. Very reminiscent of the frame relay permanent virtual circuits or the ATM permanent virtual circuits. Same thing we're talking about. Nothing's new. But that's how these virtual interfaces work. Now the public ones, guess what? Connect you to public services. So let's talk about private virtual interfaces. Well, this is to connect you to virtual stuff inside of your VPC, your virtual private cloud, otherwise called virtual private data center. Some people like to call a VPC a virtual private network. That's insanity. Here's the reason why. It's a virtual private data center. It's not just your routing and switching and encryption in your VPC. It's where you put your servers and all the things that are part of your network, which is your data center. So of course, by using private or the private virtual interface, you can use private IP addresses. Now again, you can only advertise 100 routes over the session. So what does that mean? It means the people dealing with your IP addresses can't be like a DevOps engineer that's not a network engineer. Love DevOps engineers, but that's not their world. You need to have a really good network engineer, a really good network architect, or a really good cloud network architect set up your routing. If your routing is wrong and your IP addressing is wrong, it's going to be like a city that was planned without streets, where you're trying to stick in streets after the fact. We've all been there. We all see how bad it is. So you got to have a very senior person deal with your IP addressing, subnetting, and supernetting. We'll be doing a free AWS Advanced Networking course, and I'll teach a lot more about that. Of course, if you really want to learn that, this is the kind of stuff we teach in depth in our cloud architecture career development program, the things that are really out there in deep depth, because that's architecture, whereas this is more certification materials. So let's talk a little bit more about link aggregation groups. I love link aggregation groups for the following reasons. Link aggregation groups enable you high-speed connectivity, and they remove single points of failure. So high performance, high availability. This is about as good as it gets, everybody. So if you wanted 20 gigs of network performance and you've got a 10 gig link, well, you got a problem. Now you could take two 10 gig links and set up a beautiful BGP policy and load share one subnet on one link and another subnet on another link, and that would be perfect. Or you could put two links together as a single link. And by putting your two links together as a single link, it simplifies the routing because it's going to look like one IP address on both sides. We don't have to deal with the challenging switching things like with regards to spanning tree or rapid spanning tree to promote loop avoidance. It's quite simply basically just multiple wires bundled into a single wire. And if those of you are around long enough for ISDN and multi-link PPP, it's identical technology, but with Ethernet instead of point-to-point connections. So we can bundle links up to 4 of them as long as they have the same speed, performance, and latency. So what's it going to really look like? Here's in this environment, we've created 2 link aggregation groups across 2 routers to 2 direct connection locations. Now in this particular environment, look at it this way. If on the top link aggregation group, if either one of those links goes down, the link is still up and we still have 10 gigs of bandwidth. So in this case, we've got 20 links on the gigs, 2 10 gig links on the top and 2 10 gig links on the bottom. Lots of performance, lots of capacity, and of course, higher and higher availability. And when it comes to organizations that are totally dependent upon technology, it's all about high availability, because if the systems aren't there, we don't need them. Okay, at this point, I'm going to take some questions. If you haven't given us a like, Please give us a like if you're having a good time. If you haven't subscribed and hit the bell, please do so now so you'll be informed of all the wonderful things that are coming along this way, completely free from Go Cloud Careers. Chris, I
All
can
right.
take some
So how long do you want to take questions for, Mike?
10 to 15 minutes.
Okay. And just a reminder, we will only be addressing questions for the content that we're covering.
Yes, because
If
we've
you
got lots
have-
of content we'll be covering.
If you have career-related questions, you can bring those to us tonight on our Head in the Cloud show or on one of the other Q&A session, cloud career Q&A sessions that we're going to have this week.
Many of them.
And of course, if there's a question that we'll be covering the answer to later in the content, we'll cover it then. So.
Why are demilitarized zones not used for common purpose? Cleon, in absolutely every organization that's got something publicly facing, either like remote access VPNs or a web app, demilitarized zones must be created. Now, I know in certifications they don't talk about it in depth, but it's critical knowledge for any cloud architect or even cloud engineer. And they are deployed constantly in all times where there's a public systems available. And of course, we're going to be getting much greater than WAF and SHIELD when it comes to designing a proper demilitarized zone for most organizations that require high availability and critical security and the ability to adapt to problems on demand. But we'll definitely talk a little bit about that when we get into information security, because they have to be there and must be there for every organization with a public application. And if they're not, it's because someone took a certification and somehow got allowed to work on the technology without actually knowing the technology itself, and created an environment where they're going to be hacked. It's just a matter of when, or they've already been hacked and didn't know it yet. Good question, Cleo. Question, go to the next one. When you plan on an infrastructure, hybrid full cloud or two clouds, AZ and AWS as a cloud architect, do you need to know about the pricing and cost for all services? Let's make it this way. The cloud architect's going to do the following. Meet with the customer, get their business goals, business challenges, and pain points. They're then going to go back and they're going to go to their organizations and convince their organizations that they need access to 3 cloud security architects, 2 cloud network architects, a cloud IAM architect, 2 big data people, a database administrator, 3 DevOps engineers and 2 cloud engineers, and 1 maintenance person called SysOps. That cloud architect or solution architect is then going to sell the management why they need those people and for how long they need those people. Then the group will together design the system. Then the cloud architect will document the pretty thing. If a proof of concept needs to be done, the cloud architect will manage the team of cloud engineers. They're going to do the proof of concept. Then the architect will write up the architecture. They'll deliver some presentations on the architecture. They'll respond to RFIs, RFPs, RFQs. They'll help sell and negotiate the deal. And once that deal is done, it's handed off to a build team where really great, smart cloud engineers and DevOps engineers put the pieces together. And we go design our next clients then. Good question. When you use a man-in-the-middle attack, when you use direct connection, how do you prevent a man-in-the-middle attack? Well, if I've got a wire between 2 people buried under the ground, it's pretty hard to do a man-in-the-middle attack. Now, to be fair, in 1998, I started using, in critical environments, IPsec over that direct connection. And as it turned out last year, 22 years later, or 24 years later, AWS just started allowing you to run IPsec over direct connection. And like I said, I've been working on the cloud for about 2.5 decades. Cloud networking is starting to catch up back to what we used to do in 1998. And it's getting really exciting because we're getting closer to a point where the public clouds will get closer and closer to replicating the performance and features and functionality in the data center. We're not there yet. And there's other benefits that the cloud offers in terms of agility and speed, which are transformational for businesses. But same way we always did. If it's a wire between 2 people, it's pretty hard to put a tap on that fiber optic connection that's buried miles under the ground in some cases, or under the ocean. But we can still run an IPsec connection on top of it. Great question, Elizabeth James. No. Can we connect transit gateway to 2 private subnets? Created a private VPC, created a server in one, and created SSS4C. Okay. So honestly, no, Joel, you've got so many acronyms in there. Honestly, I can't understand what you're even asking. That's why as architects and senior engineers and distinguished engineers, we don't use ever acronyms. And here's the reason why. They create errors and problems. In the medical world, we stopped using acronyms because people were putting MS for multiple sclerosis and MS for morphine sulfate, and people were dying. I will tell you in my career, half of the problems I've solved were organizations where somebody used one abbreviation and somebody interpreted it to be something else. So if you can ask us our question in pure plain English, I'd happily be able to understand it, but I can't understand through the acronyms like SSM4C2. So let's just press and move on. Which types of VPNs are you mostly use to create an enterprise level? You're going to be using all of them. You're going to be using software-defined networking, which is a form of VPN, SASE as the form of a VPN, Ethernet over MPLS, which is technically a VPN, IPsec VPNs, SSL-based VPNs. And that's why architects are not like configurers, because it's all about knowing which technology is going to improve the performance as that's best necessary for the people. Good question. Is a VPN always secure? Well, it's secure. It's point to point. So relatively secure, actually highly secure. And creating a VPN over your private connection is even more secure. Good question. Let's go to the next one. How to trace S2S. I don't know what that means unless it's site to site, but I'm not sure. VPN unstable issue, logs into which okay, so Nirmal, that I don't have time in 5 minutes to talk about how to troubleshoot an IP network. Make sure that you have strong networking fundamentals, which means knowing when to use traceroute, knowing when to use ping, knowing how to go from router to router on every single hop along the way and look at the routing tables. That is way beyond the scope of an AWS advanced networking. That's the kind of thing that we could teach in our cloud architecture development program, because I would need 50 hours to 100 hours to truly answer that question. If you have two direct connects with two different service providers, would you link aggregation group where? Not usually. So usually speaking, you should have two direct connections. If you're using different service providers, which is a minimum, you're gonna use BGP to load share. Now, if you wanted to create two link aggregation groups, which I do all the time, I might have 4 10 gig links bundled from Verizon and 4 10 gig links bundled under AT&T. And that way, if the AT&T network has an outage, we're good. The problem by using two direct connections in the same link aggregation group is as following. The following is, the latencies on both links are going to be different. And because the latencies on both links are different, then you'll have problems with regards to out-of-order packets. So generally speaking, they're on different links. Now, Chris, I'm going to get to this, dangerous question from Pradeep Kumar. He has zero knowledge on networking as cloud career right for me. Well, Pradeep, we are all born without experience. Every last one of us. None of us have the knowledge. Everyone starts out as a beginner. Everyone. Wasn't born knowing how to practice internal medicine. I wasn't born a Cisco certified internet expert. I wasn't born an enterprise architect, and I wasn't born a cloud architect. That's what training is for. We learn the skills that are necessary for the careers we want. Learn those skills for the career we want. Keep that in the back of your mind. Nobody's born knowing anything. It's been a while, but in a link aggregation group, can one of your 10 gigs slow down and you operate at 50% rather than 20%? Well, if you've got 4 10 gig links and one goes down, you're going to lose 25%. If you've got 2 10 gig links and one goes down, you're going to operate at 50%. So, no, you can't operate with whatever links aren't there. Just simple math. If you've got 4 links and you lose 3, you got 25% left. You lose 2, you got 50% left. Can I explain a link aggregation group? Sure. Add one wire, two wires, make them look like a single wire. Poof, that's a link aggregation group. And Chris, we can answer that VPN question because it's actually a good one about the throughput being limited to 1.25 gigs. It just popped across the screen. So AWS does provide a maximum of 1.25 gigs for an IPsec VPN. This is just an AWS specific thing. Their systems aren't designed to handle higher performance. We've got multiple networks where you can set up with really high performance routers where you can run full speed encryption at 40 gigs or 100 gigs per second. But that's purpose-built devices. But remember, AWS can't give you full data center performance because it's their data center and they're giving you a percentage of it. They're sharing a percentage, so they have to limit what you can do. Good question. Why is IPsec not used everywhere on the internet? It is and has been for about 25 years. First time I started setting up IPsec tunnels was 1998. Every business, for the most part, that has remote access users is using IPsec. All of them. Is a VPN like a reverse proxy? No. A reverse proxy is closer to like a load balancer. A VPN is like creating a tunnel to tunnel your traffic through the internet. Completely unrelated technologies. What would cause traffic to go in and out of a VPN? Your routing table. Here's what a routing table is. You got a list on your routers, your VPC that says, hey, to reach this subnet, go out this arm. To reach this subnet, go up this way. To reach this subnet, go down this way. To reach this subnet, go out there. So a packet's going to come in. There's going to be a routing table lookup. Poof, it's going to determine the outgoing interface and send the traffic to the next hop, which is specified in the routing table, which can be comprised of static routes and/or BGP. Inside the data center, it would use interior gateway protocols such as OSPF or intermediate systems to intermediate systems. Great question there, Hirsch. Excellent question. Is the VIF behind the scenes sitting on a router? No, it's actually in the cloud provider's network. They're going to be creating effectively virtual pseudo routers. But it's kind of like the old-fashioned frame relay thing where you connect it to the cloud and then they made these virtual links and you created virtual interfaces to connect to them. But it's really done on the service provider's background. Is IPsec the best option in most cases? No. IPsec is best when performance is not critical. And if performance is more critical, a private line is better. We can get close to private line type performance and much better than IPsec with software-defined networking or SASE. So it's really about what are the business requirements. And there's never a best option in most cases. There's always what is the business problem and what technology addresses that business problem. And that's why elite engineering and architecture are different than what's taught in certification. Sometimes the best tech is a 50-year-old technology. Sometimes the best tech came out there yesterday. Same thing for doctors. That's why they prescribe 50-year-old drugs and brand new drugs. What's best for the patient at the time? What's best for the business at the time? That's why nobody becomes an architect without studying business. Because we have to understand how we solve the business problem, but we have to understand the business before we can solve them. Is IPsec only addressed to one user endpoint? As I mentioned, we can do point to multi-point connections by creating multiple IPsec tunnels. All over the single link. Great question, Isaac.
All right, so the next one is going to be the last one before returning to content.
Dream Plan Act. Is the IPsec limitation an AWS issue? No, it's an AWS issue. Now, most cloud providers are going to have a limitation issue. That's why companies like Aviatrix come into play. That's why you've got people like me that do complicated routing with private lines. Remember, a data center that an organization owns can be the most high-performance thing in the world because they don't have to share bandwidth with anybody. But the cloud is a shared environment. It's one big data center that they quarantine off pieces and parts that they sell to other people. And because of that, they can never on the cloud give you exactly what you would get in real life because one customer could suck up the entire cloud that way. So there's always going to be limitations in a cloud provider. Now, in most cases, using the public clouds makes sense. Either in a hybrid cloud or multi-cloud environment, they can be truly transformational for a business. Truly, truly transformational for a business. But, that's the key. And then we'll get back to the content. And serverless is not the future to look into for the person that answered it. It's part of many options. And it's all about what business problem are we trying to solve, not what technology is the best. It's choosing the right technology for the right business problem. So before we get back to the content, give me a hashtag AWS Certified Solutions Architect Associate in the chat box. That way I know you're there. If you've not subscribed and hit the bell, please do so now. If you're having a good time, please hit the like button. It'll signal the algorithm that we're doing a good job, and we can get more of our free content to those people that need it most, especially those that can't afford training. We want to make sure that we help all those that need training, that are looking to pass the AWS Certified Solution Architect 2022 free training with our free full AWS course. And now let's talk about storage on the cloud. Love talking about storage, I really do. So what is storage? It's where we keep our stuff, right? Okay, so storage is in the environment where organizations are going to keep their data. Now, when we get into storage, we're going to be dealing with volatile storage and non-volatile storage. And I'm going to tell you right now that storage is an absolutely critical component of your virtual private cloud environment. So we're going to be talking about block storage, object storage, file storage. Instead of just going into the AWS terms, I want to make sure you understand these types of networks, because as an architect, you're going to have to architect around them and their weaknesses. And if you're a cloud engineer, it's not going to be good enough to know how to click a few buttons. Anybody can do that. You're going to have to know, how do you get around the performance problems of block storage? Why can't you use object storage for attaching it to a system? Why are these services used? So I want to make sure you understand it, because I want you all to get cloud hired someday as either cloud architects or solution architects or cloud engineers. So we'll begin with block storage. Block storage is non-volatile, which means it doesn't go away with system reboot or instance termination. And why do organizations use block storage? Well, block storage is a very common type of storage area network. What is a storage area network, everybody? It's basically a network full of machines called RAID arrays filled with hard drives that are attached to a network. That's it, it's network attached storage. Now, why do organizations like block storage? Well, for a couple reasons. Block storage decouples the server and the storage environment. What do I mean by decouples? In a traditional server, your storage is limited to what's inside of those hard drives in the server. But with block storage, you can have your storage, a kilometer away, and you can have your servers over here, and they can access it via the IP network, or via fiber channel networks in the physical data centers. But by doing that, we're not limited to the storage that's inside the server. So for a cloud provider, it means they can have data centers just filled with storage and connect them to a data center filled with servers, or vice versa, or put in the stuff anywhere they need it. Now, when you're dealing with this with block storage, in the storage area network, your data is taken and broken down into little blocks. And each block is going to have an identifier. What makes it even better is your blocks can be stored anywhere on the system, anywhere on the network, which means it's going to scale fast. And it's very dependable. And being decoupled, it enables your systems to grow. So I like to look at it in this visual environment. To me, I always looked at it and pictured it kind of like a calculator in my head. What do I mean by a calculator in my head? Look, in this particular environment, we've got our systems, and our data is listed as 0, 1, 2, 3, 4, etc. And that's how we can identify our data when we need it. We'll get into the AWS specifics of these storages after we do a quick overview of the data center technology. Now, while we're at it, let's talk about object storage. Object storage is a type of storage area network where your data is taken and broken down into objects. Now, object storage is very unique storage because each object has metadata. So what's metadata? It's data actually about the data, which is so cool. So when you're dealing with object storage, if you want to find something, you can query the metadata and find it much quicker. Now, because we've got metadata, we can start thinking of big data environments, data lakes, which we'll talk about, and the ability to basically take your data, categorize your data, and query your data. And in most cases, with block storage, we can even use SQL queries like we could in a database. Now, object storage, we've got to be very clear on this, is not normal storage. We can't mount it via a regular server like we could with traditional storage. It's good for static files. The reason we can't use it by a regular computer is as follows. Every time we deal with a new modification of a file or an object, it's going to create a new version. So imagine, for example, we tried to use object storage to mount it to a server with 192 cores and 6 terabytes of RAM. Now that server will have a 9 terabyte swap file. The swap file or virtual memory is typically 1.5 times the RAM, the DRAM in the system. Now that swap file may change 100,000 times per minute. So if we were to try to map a swap file on object storage, we might have 100,000 9 terabit objects per minute. Now, obviously that would cost an organization millions of dollars a month for that kind of storage. It would bankrupt them. So object storage is good for software archival purposes, backups, static web files, static website hosting, and things. So the way I like to view it is this. Object storage is flat storage, meaning basically you've got your data and something like a database pointer pointing to the data, and it looks just like this. Got a bunch of objects just sitting there with information pointing to the objects and these little pieces of metadata or data about the data, which you can see with little diamonds at the top. That's the way I visualize object storage. Now we'll talk about file storage. This is what you've got in your computer. If you're using a Windows system, it's NTFS, for example. If you're on a Mac, it's the Apple file systems, or whichever file system they're using at the time. It's traditional storage. Now also, if you've got a Windows machine and you click Share Folder, it becomes a file server. So file storage is either the hard drive that's in your systems, your physical hard drive, or you take a Linux machine and you share a folder and you create an NFS or network file system share. On a Windows system, it's a server message block share, pure file storage. And file storage is hierarchical. So typically speaking, here's the way it's going to look like. You're going to have a parent folder, and inside your folder, you're going to have another folder, and that's where you store your stuff, like many of you have them in your environment. And now let's talk about object storage on AWS. What's that called? S3. Now, I want you to understand this. This object storage is the same that you would buy from Dell EMC in your data center. It's the same stuff Microsoft calls blob. It's the same stuff that Google calls cloud storage. It's the identical technology. It's 20-plus-year-old technology. It's not new. And now you understand how you would use it on any cloud. So now let's talk about what is Amazon Simple Storage, otherwise known as S3. It's AWS branded object storage, no different than anybody else's object storage. It's integrated into a tremendous number of AWS services. AWS would call it high availability because they'd say it's 99.99%. I don't necessarily consider that to be high availability because that means you're going to have basically 50 minutes of downtime per year. So you could call that high availability. The customers that work with me would never call that high availability, but it's your definition of high availability. I'm fine with 99.99% high availability for Go Cloud careers because we're not mission critical. But in a hospital or a bank, millions of dollars can be lost with this, and a hospital, people could die like this. So it depends on your needs. Now, what I will say is AWS S3's durability of your data is truly remarkable. It's 99.9999999% durable. What does that mean? It means that even if I can't access it when I need it, AWS's systems are so backed up and so well that the chances of me needing it or not being able to retrieve it later are basically zero. 99 to 0.999, 11 nines durability, which means 99.9 to 9 decimal places out available. So this is truly extraordinary. And of course, if something goes on, you'll be notified by Event Bridge. So when would we use Amazon S3 or Amazon Object Storage? Well, to back up and archive our organization's data, for static website hosting, for distribution of content, media, or software, for disaster recovery planning, like I could take my whole data center, back it up to object storage, stick it in a cloud provider, or for big data analytics when we're talking with things like data lakes, future machine learning projects, et cetera, et cetera, et cetera. We're intentionally not using the branded names because I want you to know what this is no matter what cloud you are. So that's where we're going to talk about the concept, because nobody's going to care if you go on a job interview if you know the names of the services. What they are going to care is, do you understand how they work and do you know how to use them? On your exams, you need to know the name of the proprietary services. So when you're dealing with S3, you understand that basically what's happened is it's organized into buckets for you, the user, to look at it. Now, in reality, it's flat environment where basically there's the data and a URL pointing to the data. But that's just for us. But for us, that we can put it in a bucket and make it feel good. The bucket is really just a container for our stuff that's stored on AWS 3. What'll happen is the buckets are given a top-level namespace, which is basically speaking a fully qualified domain name. ec2.gocloudcareers.com, fully qualified domain name. We'll get into that in more depth with fully qualified domain names when we talk about DNS, and we're going to cover that heavily and all the routing types when we get to that section. Now, when you name a bucket, it can have upwards of 63 characters, including letters, numbers, and hyphens and periods, so we can be pretty descriptive about it. But remember, the path where you store this stuff is not necessarily where the actual object or file is located. Now, the URL that's used to access your file, again, is just a pointer in the database to where it's truly stored. S3 is a lot like a database behind the scenes, as is all as object storage, in that you've got your data, you've got a pointer to it. And here's the good news. Because it's so much like a database, you can run SQL or structured query language type queries or searches on your data. Now, an organization can have 100 buckets per account. And if you need more than that, all you need to do is reach out to AWS support, and they'll give you a bucket increase, so you can have more buckets. So let's talk about securing your data. You're going to have two options. You can run a bucket policy, which is the preferred method, because it's very granular and it's based on identity and access permissions. What is identity and access management? Who are you? What are you allowed to do? And then logging what you did. We'll talk much more about that when we get to the security section. Or you can use those same Unix, Windows, ACL-based permissions, which are basically read, write, and full control. So it matters. I'm going to tell you right now that lack of understanding of object storage, it causes most of the hacks on the internet. 16% of all cloud hacks are related to misconfigurations. Anybody can configure this with 3 minutes of training. What they can't do is know what to configure and why they're configuring this, which is exactly why we're focused so much on the concept. Like I said, you can do those free lab downloads, sign up and do all those labs and practice them. But if you don't understand what it is, you don't pass an interview. And for the solution architect or the cloud engineer, knowledge of how the systems work is the most critical. Now we're going to talk about different storage classes on S3. And why is this? Depending upon your needs and your performance, there'll be different options for your object storage inside of S3. By doing so, the whole point is to get the lowest possible cost for your demands or your customers' demands. And in this section, we're going to be talking about a lot of object storage options. We're going to be talking about S3 standard, your highest performance. We'll talk about S3 and frequent access. Then we'll get into the scariness of S3 and frequent access with one zone, which was reduced availability storage. Then we'll get into S3 intelligent tiering. Then we'll get into Amazon S3 Glacier Flexible. And of course, we'll deal with Amazon S3 Instant Retrieval as well. So what is Amazon S3 Standard? Basic, simple object storage. It's high availability, or at least 99.99% available, which some people would call high availability. It's incredibly high durability, that 99.119 durability, which means 99.9 to 11 decimal places. The performance of it is acceptably good for most applications. And it's what you use for frequently accessed data. And here's the reason. If you're going to be accessing your data, you can access it as much as you want. They don't pay you to pull your data once it's stored there, to put it there or pull it there. No, if it's transferring the network, yeah, there will be. But in this case, that's going to be your cheapest option in most cases. So while we talk about S3 storage tiers, let's talk about the next option, infrequent access. Now, again, this gives you your same availability and durability as before, and performance. Now, if you're using S3 standard infrequent access, you're going to pay a lower rate to store your data, which is great, but you're going to pay to retrieve your data, and your data is instantly available. So imagine it this way, and we'll talk about lifecycle security, lifecycle policies, and why and how they can be used to optimize your customer systems. But here's what we're dealing with. S3, you pay less, but then you got to pay to retrieve your data. Now, here's the thing. If you're not retrieving your data a lot, it's cheaper to use S3. But if you're pulling your data constantly, it's too expensive. So this is for data that's infrequently accessed. And we'll show you lifecycle policies before and how you do this to really save an organization money. And this is one of the things that's transformational in the cloud. Now, the next access we're talking about is S3 and frequent access one zone. This terrifies me because now you reduce the availability of your data, which means when you need it, you're not going to find it as easily. Now, when you deal with one availability zone, you're typically dealing with 99.9% performance, which for the most part is 1 day of downtime per year. So if you can tolerate that, it's cheaper, if you can tolerate it. And that's kind of our thing. Now, while we're dealing with this, you get the cheapest pricing, but you got to pay for your data. And the availability is going to be substantially less. So keep that in the back of your mind. And then there's something called S3 intelligent tiering. This is the auto magic thing where AWS monitors your data and they automatically place your data on wherever they think it's the most cost-effective performance for you. And this is cost optimization managed by your service provider. Well, I think that's like having the fox guarding the hen house. They're going to optimize it for you, the people that are getting paid to do it. So, it's a service. It's a machine learning-based service that may not be great for you, but kind of keep that in the back of your mind. If you know your data and your usage policies, it's probably best to create something manually. Now, if you're looking for really low cost, we've got S3 Glacier, which is good for long-term storage. In fact, it's where you put your stuff and you pay less to have it there. Now, it's instantly retrievable. As a rule, it costs 68% lower than S3. But to retrieve it, now you're dealing with some heavy-duty retrieval fees. Kind of keep that in the back of your mind. But if you don't retrieve your data for at least 98 days, then guess what you got? You've got much lower cost, up to 68% lower. Now let's talk about S3 Glacier. Flexible, that's traditional Glacier storage, meaning you pay less to keep it there, but it's not instantly available. In fact, you've got this really cool thing called the vault lock option, which makes your data immutable. So let's think about that and making your data immutable. If your data is immutable, it can't be changed. So for a bank that needs to store their customers' records, the Glacier Vault, lock option, beautiful. For a medical facility that has to store their patient records for 7 years, Glacier Vault puts it in a place where it can't be modified. Brilliant option for the right places. Now, this is designed for information that's going to be accessed 1 to 2 times per year. If somebody needs their data, they can retrieve it in minutes to hours, and it's really low cost. It's going to be even 10% less than Glacier Instant Immediate Retrieval. And you can pay for the data retrieval, but you're going to have to request information when you're done. Now, when we're dealing with SC Glacier Deep Archive, remember, it's the lowest cost. but it's designed for stuff that you don't need within 12 to 48 hours, because that's how long it could take to get it. And your data is going to be stored in 3 or more availability zones, and it's designed for long-term storage of highly regulated industries. So let's talk about lifecycle management, and I've got a visual that we'll use for this. What are we dealing with here? Let's say an organization knows their usage flows of their data. Let's say that the organization knows they have data that they're going to frequently access for 30 days. So they're going to put it in S3. Let's say for the next 30 days, that information is going to be accessed just a little bit. Guess what? That's terrific. They can put it in infrequent access. Let's say 30 days later, they're never going to use that data ever again, but they want to store it for archival purposes, maybe future machine learning purposes, maybe, backup purposes. Maybe they need it for regulatory environments. So that's what a lifecycle policy is. We can manually set it up, minutes, it's simple to do. Stick your data on one, migrate your data to the next, and have it automatically managed to pay the lowest price based upon an organization's uses of their actual data. So, while we're at it, let's talk about S3 versioning. You gotta love when a manufacturer or a brand like AWS decides to create a feature out of the natural functionality of the technology itself. So when you're dealing with object storage, all object storage automatically creates new versions every time something's modified. Now, of course, the cloud providers have taken big gains to prevent that from happening, which basically means they know that their customers would be really upset if they filled up their systems and got multi-million-dollar bills per month because their storage got there. So they automatically delete old versions. But if you want to basically keep all copies of something, you can turn on S3 versioning, which is the default behavior of object storage anyway. So let's say I wrote an example, the CSA doc, Certified Solution Architect.doc. And let's say I worked on it for an hour, saved it, I'd have version 1. Then Alonzo from my team worked on it for an hour and it's version 2. Then Chow worked on it for an hour and it's version 3. Then Chris worked on it for an hour and it's version 4. Now Eddie, who's in Cameroon, worked on it and it's version 5. Leo, who's in Brazil, worked on it, it's version 6. By doing that, you would store each version. And why is that good? Well, if version number 642 got corrupted, you can go back to 641 and you still got something. So that's what versioning is. And it's the default behavior on all object storage platforms. Now, let's think about security of your data. Now, there's 2 ways that you can use your data. I could just let you delete a file directly from my object storage bucket. No big deal. Simple, easy to do. But imagine that. So let's say we're talking about Super Chow. Chow is this rock star cloud architect on my team. She's amazing in every way. Let's say she was mad at me one day and she just wanted to delete a file. And she deleted the file. Chow would never be mad at me. She would never do this. She's amazing in every way. But, here's that. Now, if we had multi-factor authentication delete set up, Chow tried to delete a file, and I would get sent a challenge. And they would ask me for a one-time password. Now, I could provide that one-time password, and that file would be deleted, or I could not provide that one-time password, and the file stays there. So that's when it works. Multi-factor delete, multi-factor authentication, again, is nothing new. And it's done to prevent other bad actors from doing it, or you yourself. How many times have you accidentally deleted something and then I had to go into the trash can to pick it up? I've done it before. So that's the point of multi-factor authentication delete, but it also gives you protection from others. So let's talk about organizing our data into S3. When you organize it, remember S3 is flat. You just put your stuff in the object storage. And the reality is there's a database pointer pointing to it. But that's going to be hard for the user to use. It's going to be tough. But we can use what's called the delimiter, which is a pointer to our data. And by doing something like that, it can feel logically organized like a folder. I'm going to put one right now, a basically fake one that I just made up in the chat box so you can see it. So here, if I use a delimiter, which I did in the chat box, Mike/2020/AWS video/storage/s3.mp4, What I popped in that chat box, you can see it looks and feels just like a Unix path. Well, it's not, but I can make my users feel like they're using traditional storage. And this is the same thing that happens if you use Dropbox or Google's cloud storage or anybody else's storage. It's all the same because it's all object storage. The Apple Cloud is all the same. iCloud, for example. Now, if you're going to have your data on S3, and somebody were to break into AWS and steal their hard drives, for example, your data would be there, and that would be bad, bad, bad. Now, of course, your data would be spread across RAID arrays, which make only partially the data active, but still, that's a problem. So you're going to protect your information with encryption. And encryption basically takes something and turns it into something that's not usable unless you've got the decryption key. Kind of like those old serials where you'd have a message and you need to buy the box of cereal to get the secret decoder ring to read it. It's the same thing. So we're going to protect our sensitive data with encryption. And encryption will make your data completely unusable without the decryption key or that secret decoder ring. Now, there's lots of forms of encryption throughout history. There's a martial art called capoeira in Brazil, and that was designed not to look like a martial art. There's languages like patois in the Caribbean, which were languages which were a form of encryption that certain people would understand how to speak and others wouldn't. Now we've got encryption via IPsec, SHA-256, and many other encryption algorithms. Realistically speaking, that's all we're talking about. Now, we can encrypt it on the client side before we send it somewhere, or we can encrypt it on the storage server, and we're going to be talking about them. Now, you'll definitely see this in the Certified Solution Architect Professional exam. You may actually see this in the Certified Solution Architect Associate exam as well. The first type of key encryption we're going to be talking about, and I didn't make up these terms up, is SSE-KMS. Again, I don't make up these names. And this is realistically a customer-managed key within the AWS key management system. Now, this is a complete key management system, meaning the user manages the master key, and the key management system controls the data key. And this provides a beautiful audit trail of how, who, and when the data was accessed. And it's going to look, realistically speaking, like this. Got the AWS key management key. There's a customer managed master key. And then data key is used to, basically speaking, encrypt your data. Simple and effective. Now let's talk about another version. And again, I didn't make up this term. SSE-S3, AWS Managed Keys. Now, this is an incredible complete key management solution. Now, it's not going to be for ultra-high security environments where you need control of your keys. But for most people, this is simple and elegant. Basically, the key management systems will manage all keys. It will automatically rotate your keys. And every object is going to be encrypted with a new encryption key. So, wow, you implement this solution, the computer system automatically manages it for you, and you know your data is safe and secure. This is probably one of the best solutions for average organizations. Not good if you need military-grade security or things like that, but under normal environments, this is simple, elegant, and really effective, and it reduces your overhead. Let's look at it this way. Basically, we've got the key management system. It literally manages the master key. It manages the data key, and everything is done for you automatically, as they like to say. And no, I never would use the term automagic, but lots and lots and lots of people like to use the term in tech, so I thought I'd give you something that would be a little fun. Now, the next option we have, and this is going to be what's going to be used in your critical environments, military-grade security, is something that's going to be called SSE-C, and this is really customer-provided keys. Now, this gives the customer complete autonomy over the encryption keys. The customer is going to manage all their keys. Now, here's the downside of that. Lots of actual key management going on here. Kind of keep that in the back of your mind. So how do we optimize and tune S3? Well, We're going to talk about pre-signed URLs, multi-part uploads, range gets, as well as cross-region replication. So what is a pre-signed URL? Let's say I want to send Superchild, the amazing cloud architect, some information. I've got two options. I could give her the keys to get into the system, or I could pre-sign the URL and send my pre-signed URL to Superchild, the amazing cloud architect. So how would I do this? I sign the object with my own encryption key, and I send that URL directly to Chell. The URL is a fully qualified domain name. She could click on this, and then she could download the photo of my cat, which is probably what I would send Superchild, a photo of my cat, because I love to send photos of my cats to everybody, especially the people on my team. Still love my cat. But by doing this, by pre-signing the URL, I'm giving Superchild secure and temporary access to my content. Now, how long is this content actually available? Well, it depends on the method that I actually sign it. So if I sign it with my IAM instant profile, again, identity and access management is, who are you? What are you allowed to do? And what did you do? And we'll talk much more about that when we get into identity and access management. But if I sign it straight with my profile, it's good for up to 6 hours. Now, if I use the security token service, and I promise you we're going to get into a lot of detail of the security token service when we get involved in security and identity and access management, then it's going to be good for up to 36 hours. Now, what if I sign it with an IAM user? Name Chell's an IAM user of our systems. Well, you can have access to that link for up to 7 days. Or I could issue a temporary token, and I love temporary tokens, and here's why. I give something, it's available for a short period of time, then it's not available, and poof, it is done. And that's why we really love these things, the AWS temporary tokens, because somebody steals your token, they can only access it for a short period of time, and then we're back to normal. Now let's talk next about multi-part uploads and what they are. Well, with S3, we can deal with a file size that's up to 5 terabytes, but we can upload a file up to 5 gigabytes. Now imagine this. You send 4.75 gigabytes over the wire, and the network connection goes. Do you know what's lost? All 4.75 gigabytes. And that's not an efficient system. It would be much more efficient if we can send little bits and parts of the file and then reconstitute it in the end. See, there's so many things that can go wrong with large file transfers. And that's why AWS recommends you use a multi-part upload for all files over 100 megabytes. And let's look at what that actually is. Again, it's a very, very simple concept. We've got our file over here. Our file gets split into multiple parts, and it gets put back into the big, beautiful file, the same file it was in the beginning, and then sent to object storage. Why do I love this so much? Why is this so great? Because let's say from the top to the bottom, you've got 4 file parts. Let's say file part 3, which is the second one from the bottom, gets lost in transmission. By doing so, we don't have to retransmit the entire file. We only transmit file part 3, which is the file part that was lost, making our transfers more reliable and more efficient. And that's why we use multi-part uploads for all files that are greater, or uploads that are greater than that are greater than 100 megabytes, making sure we don't have network transfer problems. So let's talk about the last one, which is cross-region replication. When we're dealing with cross-region replication, what we're doing is we're taking our data stored in one region, which again is just a large geography, and replicating it to another one. Why would we want to do this? Well, if I'm in the US East region and I replicate to US West, well, guess what? Guess what? Then if US East dies, I still have US West. But what else are we talking about? When we're dealing with cross-regional charges inside of the cloud provider, they charge you to send your data across regions. And let's say you had some object storage. It might be cheaper to keep your object storage replicated in 2 different environments than it would be to pay all those inter-region charges. Again, this is 100% based upon the use of your data, the specific use case, and where your users are accessing things. But Cross-region replication gives us good disaster recovery abilities, but it might be cheaper if we're dealing with a lot of interdepartmental transfers, and if we're dealing with users in Japan and then users in New York City. By replicating the region, the information from region 1 to region 2, the users in Japan are going to get fast, low latency access because they're not going to be traversing the entire AWS global network to get it. They're going to go to something in Japan. Likewise, the people in New York or New Jersey could go to the bucket in the region that's closest to them. So that's why we're dealing with this. So we talked a little bit about storage area networks. We're going to talk more about storage area networks today, get into instance storage and block storage and all kinds of cool, exciting stuff. But I figure now is a good point to take some questions for a few minutes.
All right. How long do you want to take questions for, Mike?
10 minutes.
Okay. And same instructions as previously. We're only going to be addressing questions that are related to the content that we're covering. And if the questions will be about future content, we will address them when we cover it in the future.
Absolutely. While we're at it, and Chris is looking for questions. If you haven't given us, if you haven't liked, commented yet, please do so. Like it, the webinar if you're having a good time. Hit the bell and subscribe if you want to be informed of more free training. Denise 638, you can use AWS and Azure together, but can you use AWS EC2 and EBS for the main and then you use Azure as a disaster recovery and set up to wake up? That would be one option that you could do. Or you could put half of your eggs in one basket like AWS, half of your eggs in the Azure basket, which in most cases is the smartest thing to do. And that way when AWS goes down or Azure goes down or one of them gets hacked, you're up and fully operational. So there's lots of ways you can do it. There's lots of types of disaster recovery options. I've got some videos on this YouTube channel you can look for disaster recovery options, basically your 4 types. But in most cases, for most businesses, it's going to make more sense to use 2 clouds active, and less resources per cloud than it would be to put all your eggs in one basket, have that basket go down, and then take 45 minutes or more to bring up your second cloud. Because that could be millions of dollars lost for an organization, or for a healthcare organization, that can mean people die when the single cloud goes down. And all clouds go down. AWS, Azure, and Google Clouds have all been down. The entire clouds, affecting at least global parts of the networks periodically. Because here's the thing. When you're dealing with networks and data centers, you must plan on failures occurring. You must. That's why for the last 25 years, we network architects have always told our customers and the service providers themselves, don't stick all your eggs in a single service provider. And it would be reckless to put all your single things in a single cloud, no matter how many availability zones and regions, because if the cloud gets hacked, you can take down the whole cloud. If the control plane that orchestrates the cloud goes down, guess what? The cloud can go down, again, causing you a problem. Or if there's a network issue, the cloud can go down. So lots of things can take a single cloud down. Can you store static content only on S3? You could, but you might want to put it in file storage or block storage, depending upon what your use case is. So you could. The question is, what's right for the business? And that's the key question to ask. How to retrieve something from S3 Glacier or Deep Archive? Just a simple retrieval. You use it like you would do anything else. Does AWS have any service to split large files more than 100 mega, or is that the cloud engineer job? That's what's called multi-part uploads, Jasper. That's why we covered it. That's their service. You have to enable them. Why wouldn't you always use? You would always use them for file uploads that are greater than 100 megabytes, and that's what we're talking about them. But for smaller files, it doesn't make sense. Good question. You should always use them. Does taking this course give you a better understanding when it comes to software architecture? Absolutely not. We're talking cloud architecture, not software architecture. Software architecture is an entirely different career. Just like training to be a cloud engineer does not make you a cloud architect, and training to be an airplane pilot does not make you a flight attendant, and going to law school will not make you a doctor. This is teaching you cloud computing, not software architecture, totally different career. Good question, though. I'm Mike. Enabling S3 versioning will store multiple files with different versions, so it's going to consume more spaces. Yes. Example, it's going to consume a lot more space. That's the whole point. You're paying for more, but you're getting greater system reliability, because if one of your versions gets corrupted, you can go back to another version. So again, what is the business case which substantiates whether it's paying more or is it not worth it? And I don't know that, and you don't know that until you ask the customer the criticality of their data, as well as their other backup and archival strategies. Good question, Michael. If object storage is used for static content, what is the use case for block storage? We're going to get there. Well, block storage is a storage area network that's going to be used for dynamic content. And it's going to be a low performance virtual hard drive that we can talk about for our systems. And we're going to get to that today. So let's go to the next section. Is each part of a multi-part? I honestly don't know if it does cost or not. I am an architect. I design a solution. I'm not dealing with the pricing strategies. Cloud architects and solution architects like me have internal sales engineers that calculate the bill of materials and what the stuff is going to cost. We deal with the overall global picture of design, so this is not something I would know about. I don't know how they charge for block storage. Again, that's something that's far from an enterprise architect's world like me. But I will tell you, sometimes it's cheaper to be in the data center, and sometimes it's cheaper to be in the cloud. And it's all dependent upon the use of the information and the business requirements. Cloud is not always cheaper. Sometimes it's more expensive, sometimes it's cheaper. Yes, this is a complete session. It's going to be 5 days long, multiple hours per day. And then there are labs. Now, this is not enough to be hired as a solution architect. That's going to require a lot of business acumen training, leadership training, sales training, executive presence training, CXO relevant training. But this is a full course to easily pass the AWS Certified Solution Architect Associate, and then some, almost to the Certified Solution Architect Professional. You're a software engineer, but you're sitting on this because somehow this stuff comes up anyway. And Kristen, if you're a software engineer, I generally recommend you focus on software engineering. Having said that, to some degree as a software engineer, you need to know where your stuff is put. Isn't it a virtual machine? Is it going to be a microservice-based application? And if it's a microservice-based application, it would be helpful to have some knowledge of Kubernetes and deployment of these microservices. But whether you're a software engineer in the data center or a software engineer on the cloud, it's the identical job. It's the same coding and the same environments. It's just, where your virtual machines are housed or where your containers are housed. In a data center, you could be using OpenShift, standard Kubernetes, Docker, for example. On the cloud, you could use a cloud-managed Kubernetes service, or you can implement your own robust Kubernetes service across multiple clouds. You can still use your same Docker, or you can do anything you want. Same concept. The same concept like the Who song. Meet the new boss, same as the old boss. So yes, Kristen, I love that you're here. I'm thrilled that you're here. Background knowledge in the cloud is good, but for software engineering careers, focus on software engineering. Internally, you download any of this stuff is simple to use. That's why we're going to the cloud, in many cases paying 3 to 10 times more for the cloud services, so you don't need the expensive people. Because anything on the cloud is pretty much you can do. Like I said, I've taught an 8-year-old how to configure, in literally speaking, less than 5 minutes. She set up S3 buckets and EC2 instances, nothing else easy to do. Yes, this course covers all of the new services in the SAA-CO3 exam version? Absolutely. That's why we updated it. IAM Instant Profile is 6 hours. As I mentioned, the AWS Security Token Service is upwards of 36 hours. Good question, though. And I'm going to address Kristen's issue real quick before we get it. Kristen, I've interviewed 6,000 people in my last 25 careers. And I'll tell you one, people that focus on their jobs do really great in their careers. And people that focus on trying to learn everybody else's job, I can't hire them. And when I can, I have to pay them half of somebody that knows how to do their job. And here's the reason. If I want an architect, I need an architect. If I want a DevOps engineer, I need a DevOps engineer. If I need a pilot to fly an airplane, I don't care if they were an airplane mechanic or a flight attendant first. It doesn't make them a better pilot. I will tell you that I've doubled and tripled people's salaries after being in tech forever. And the biggest career mistake I've ever seen is when somebody focuses on learning somebody else's jobs. Because here's the thing, when you're good at somebody else's job, you're not good at your job because you can only focus a certain amount of time in a certain amount of place. So Olympians train for their job. They don't train for everybody else's. We've got lots of career things that we're going to be doing. I've got 20 years of helping people get their first tech job, get promoted in tech. I quite frequently increase people's salaries by $100,000 a year for training that costs less than $1,000. And I'm going to be here tonight dealing with as much free question and answers on cloud architect and cloud engineering careers. I'll be here tomorrow morning dealing with a tremendous number of career questions, which is what I love to do most of the time. And on Thursday, I will be dealing with how to get your first cloud job issue. And on Friday, I'll be back to answer many where cloud architect and cloud engineer career questions. But during these sessions, we're going to focus on certification. But join us tonight. We will tell you what you need and how you can get hired, how you can get paid more, how you can get promoted faster, and how when everybody else is waiting for jobs for 10 years, you can get them like that. How do you decide to store which region where your data is in? Where's your customers? Put it as close as possible to your customers. Put it where your customers are. Of course, we're going to do another one. And then I think you're on track of time. And Kristen, I didn't mean to come across and offend you. I'm just telling you that I've spent 25 years trying to solve people that made that mistake of focusing so hard on trying to learn everything. Because here's what happens. When you try and become a jack of all trades, you become a master of none. And the problem is, as a hiring manager and someone that's done 6,000 interviews, I want you all to get hired and paid more and promoted more. And that's why I'm here, doing this completely free to try and help you build a career so you're not struggling 10 years from now. Exactly.
All right. So yeah, time to get back to the content.
So now we're going to talk about instance storage. So what is instance storage? Well, if you've got a virtual machine or a server, it's the storage that's sitting inside your server. Now, here's the thing. It's fast. Real fast, real fast, real fast. Fast, 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 fast. How fast is instant storage? Well, let's put it into context. We're going to be dealing with EBS block storage. The fastest storage volume you can get is 250,000 IOPS. Now, you can go to Best Buy for about $100 and buy a Samsung 980 Pro, which gives you about 1 million IOPS, which is 4 times the fastest block storage. Now, when you're dealing with instant storage, what you're dealing with is a RAID array it's typically 8 of these drives in a RAID environment. So you might have 6, 7, 8 million IOPS just sitting inside the server. So instant storage is fast, 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 fast. Where block storage is slow, 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 slow. So why don't we use instant storage? Instant storage. And here's the thing. The thing is as follows. Whatever you store in instant storage is deleted upon instance termination. So unlike your data center where you store your stuff in the NVMe RAID arrays that are sitting inside of your servers, in the cloud, every time you delete your system, it's all gone and you lose everything. So this makes it not feasible. So that's why we need to get really, really, really through what we're talking about here. So let's talk about elastic block storage. What is block storage? Block storage. It's the same block storage that's been around for 20 years in every data center in the world. It's nothing new. Why do we use block storage? As we talked about before, it decouples your servers and your storage environments. And by doing so, it means that the data centers can scale easy. Now we're going to mount block storage in our devices. And remember, block storage is slow regardless of what's taught in your certification course. It's going to act like a virtual hard drive. So what are we going to use it? We're going to be sticking it on our virtual machines, which are otherwise called on AWS EC2 instances. Azure calls them virtual machines. Google calls them compute engine instances. It's identical technology as all clouds for the most part are the same thing. Network in a data center has been virtualized, where they have new names for the same technologies. So block storage is scalable, real scalable, and it's not deleted upon instance termination. And this is high availability storage. And what we're talking about this is it's 99.999% available, which means it's there when you need it, except for about 5 minutes and 15 seconds per year. That's relatively good high availability storage. Having said that, no cloud provider has been 99.999% available for the last couple of years. So it's really not going to be anything that's that high availability in practical purposes. But according to the exam, it's 99.999% available, and let's teach that. Now, on your exam, you can think of block storage, which AWS likes to stick the term elastic before, and they call it elastic block storage. They'll sell it for high throughput and high transaction workloads. It's the best you can do on the cloud. And we're going to teach you how to work around the weaknesses of block storage too, because it's so critical. With block storage, you're going to get multiple performance options, all slow, but compared to data center technology, but some are slower than others, and some are cheaper than others, and some are more expensive than others. So basically, block storage is going to be associated with a single availability zone or data center. And basically, realistically speaking, it's going to be backed up to another availability zone or data center. So that's good news. What's in one data center will be copied automatically to another data center. Now, what's also very, very, very cool is the way your block storage is automatically going to be backed up in terms of snapshot. Why is this so cool? It will be transferred to object storage. Whoa. So your block storage automatically gets sent into S3 or S3 Glacier, wherever you want to pop it. And now, wow, if something happens to your systems, you've got another one. Now, these EBS volume snapshots are truly, truly amazing, because it's not like you ran backup software and you backed up, and backed up stuff, okay? That's not what we're actually talking about. It's a full system image, like a ghost image or a system image that can literally be rebooted, which can be just relaunched, and then poof, a virtual machine will come up with the identical hard drive and everything else you need. So AWS gives you some of the most brilliant and beautiful backups. All the other cloud providers do too, but this is simple and elegant and typically speaking about 1,000 times better than most organizations and enterprises' backup strategy. So love this. So how do you choose your EDBS volume types? Well, it's going to be your performance requirements, and your performance can be trained as both latency and throughput. And they're not the same. So latency is going to be measured in input operation and output operations per second. What does that mean? How many times can you read write to the disk? Read write. The higher the number of read-write activities you can do per second, the lower the latency. By comparison is throughput, which is how much stuff can you move per second. I like to use vehicles to explain the difference between latency and throughput. So let's say I'm here and I want to take a car full of cat toys from Palm Beach, Florida to New York City. So I get in my car, I shove my car full of cat toys. And my car is, let's call it a sports car. It's not, it's an SUV, but it's a high performance SUV. So let's say I shove my SUV full of cat toys and I get to New York City. Now the reality is, to New York City, I can drive my car probably at 100 miles an hour before the police stop me between Palm Beach and New York City. And I'm going to get there relatively fast. My car is designed to be driven on the left lane of the Autobahn where there's no speed limit. But let's say I wanted to drive between Palm Beach and New York and I could average 100 miles an hour. The latency to get to New York is going to be lower. Now, by comparison, let's say that my buddy owns a tractor trailer and he shoves this tractor trailer full of cat toys. Now, he drives that tractor trailer at 70 miles an hour between Palm Beach and New York City. When that trailer gets to New York City, look at the stuff that it carried. Every cat in New York and New Jersey is going to be having a party time with their cat toys versus my SUV that may take care of, a couple of cats in Brooklyn or Manhattan. The throughput is greater in the tractor trailer. The latency of the car is faster. So now you know what latency is, the speed that you can do something in terms of input output per second. How fast can you get somewhere versus throughput is how much stuff. So input and output operations per second, which is inversely correlated with latency, is going to be measured in IOPS. And throughput is going to be measured in the amount of stuff you can move. And that's going to be in gigabits per second or terabits per second or megabits per second. So when we go through these things, we're going to talk about latency and throughput. Now, the fastest block storage you can get in AWS is EBS provision IOPS. It's called IO2. This is their highest performance SSD storage. They consider it the lowest latency, and it's designed for workloads that require high input and output operations. They'll tell you it's good for large databases. They'll tell you it's good for applications requiring low latency. And they'll tell you it's good for 4,000 megabit per second, which is decent throughput, actually. And a 250,000 IOPS, this is acceptable. Now, this is nothing like you can get in your own private cloud, like with any Nutanix cloud, for example, where you're running all of this stuff. And in these particular environments, that's what we're talking about. So, 250,000 IOPS, not very fast, but relatively quickly. It's going to be a problem in many business applications because it's still too slow. And that's why we're going to talk about RAID. RAID is not covered in the Certified Solution Architect Associate, but you need to know it for real life. It is also covered in the Certified Solution Architect Professional. So we're going to be explaining that to you when the time comes. So this is the fastest. That might be a few $1,000s per month to get this. And mind you, it's going to be slower. That $150 drive you could buy at Best Buy, like a Samsung 980 Pro. Now, by comparison, the old fastest drives that we can use EBS volumes, it's about 2 years old, were the EBS Provision IO1 devices. And that's going to be, relatively high performance. And I say that, with cringing. SSD storage is designed for low latency. It's designed for workloads requiring high input and output operations per second, like databases and applications that require low latency. Look, the max you can get here is 16,000 IOPS, which is nothing. But it's the second fastest block storage you can get on the cloud. The throughput on this thing is acceptable at 1,000 megabits per second. Look, that's not going to be problematic for most applications, but you're going to have massive problems when you're dealing with, low latency in these environments. Now let's talk about general purpose SSD. Instead of these other drives, which are based upon non-volatile NVMe drives, this is going to be based on traditional SSD storage. Now, when you're dealing with SSD storage, you get decent throughput. You get much lower latency, which means higher IOPS than magnetic storage, but much lower than you're going to get from NVMe. moderate throughput, like 250 megabits per second, which is what you'd get a little better than a standard magnetic hard drive. This is fine for a transactional workload. It's good for a development and a test environment because it's cheap and it's relatively low latency, we can call it that. And now we can get into our magnetic storage options. Now, this is an interesting one. We've got EBS throughput optimized hard drive. Relatively low cost magnetic storage. Because it's magnetic, it's going to be high latency, which means low IOPS. Now, the throughput on these things isn't bad, 500 megabits per second, which is right up there with the standard SSD drive, because these are obviously sitting in RAID arrays. So this is really good for a frequently accessed workload or a throughput-intensive application like video, for example. It's great, great, great when it comes to throughput-intensive workloads like a video editor would use, transferring large video files. Great for large log storage, great for sequential reads and writes. So kind of keep that in the back of your mind. And then the next option is EBS cold storage, which is going to be your lowest option, low IOPS, low throughput, 250 megabit per second, and it's going to be used for workloads that are not accessed frequently. Now, because I told you right now, look, what are you going to do when you have a business application that requires 2 million IOPS on the cloud? Well, you don't get high disk performance on the cloud. So the only way you can work around it is either use a private cloud like OpenStack or Nutanix in your data center for your high performance latency sensitive applications and use the public cloud for non-latency applications. Or if you're going to be on the public cloud, no big deal, use RAID. So we're going to do a brief introduction of RAID. And then from there, where are we going to go? We're going to go into things. So what is RAID? RAID, or redundant array of inexpensive disks, is really a means to combine multiple hard drives into a single hard drive for multiple performance. And they're still going to be separate drives, but we're going to take separate physical devices and logically associate them as a single device. On the cloud, everything's virtual. We're going to have virtual block storages, and we're going to combine them in the same manner. So there's going to be multiple performance options for redundancy. And there's going to be 4 main RAID types that the entire world uses. Now, we're going to be dealing with 0, 1, and 10 on the cloud, not RAID 5. But if you're a cloud architect or a cloud engineer and you're going to be moving stuff from the data center to the cloud, you better know what RAID 5 is because it's used everywhere. The only reason we can't use RAID 5 on the cloud is because the cloud storage is so bad in terms of performance with regards to latency. We can't deal with the additional latency overhead of RAID 5, but widely used in the enterprise. So let's talk about RAID 0. RAID 0 is called striping. And I'm going to show you what that looks like. But basically, you're going to be taking your data to multiple hard drives. Right to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And by doing it, you're load balancing the load across multiple drives. When you load balance, you get lots and lots and lots of speed. Lots and lots and lots of speed. Because of that, you're there. So when you do this, you get no fault tolerance either, because if one of the drives in your RAID array fails, you lose everything. So no fault tolerance. But it's good when ultra-fast speed is needed. But if you're going to use RAID 0, back up, and back up some more. So what's it going to look like? It's going to look like as follows. Store your data from block 1 on drive 1, block 2 on the next drive, block 3 on one drive, block 4. By doing this, you're going to get twice the throughput and lower latency. So great way to accomplish around this. You've got 250,000 IOPS drives in the cloud. Now that will equal to what you can get from that $150 drive at Best Buy. Now, of course, it might cost you $30,000 on the cloud to equal the performance of a $150 drive from Best Buy, but you can still do it. Like I said, it's all about knowing as an architect, where do you put your stuff? How do you architect it for maximum performance at the lowest cost? And what drives that? The business requirements, nothing else. That's why business acumen is so critical for the cloud architect. So let's talk about RAID 0 in the cloud computing environment. It's a little less bad than the normal environment, and here's why. In the normal environment, if one drive fails, you're done. But you got to remember, these aren't actually physical drives. They're virtual drives that are high availability, so they could be a little better. RAID 0 is generally too risky for the enterprise, unless we're going to get into RAID 10. Exception is temporary storage. Video editors use RAID 0 all the time. When I used to edit my own videos, I had my own RAID array that was RAID 0, and I backed up to a RAID 5 RAID array. Good news is we can back up our RAID 0 into a single availability zone. And because they're logical rhymes, it's less risky, but still it's too risky for use for production environments. Now this gets us into RAID 1, which is going to get us into some really cool availability, and it's the secret to RAID 10, which is coming up. Now RAID 1 is disk mirroring. What's mirroring? 2 hard drives in the system. Whatever gets written to hard drive 1 gets immediately copied to hard drive 2, and that way if hard drive 1 fails, you just break the mirror and use the other hard drive. It's brilliant in terms of redundancy, but it's slow, it's expensive, and it has low capacity. And here's what I mean by this. Normally in RAID 0, you've got 4 2-terabyte hard drives. Guess what do you have capacity? 8. Here you've got 2 4-terabyte hard drives. What do you get? Capacity-wise, 4. Because you're getting one and it's backing up to the other, and that's it. So what's this look like visually and architecturally? You've got 2 drives, hard drive 1 and hard drive 2 here. All the data from hard drive 1 is exactly mirrored and copied to hard drive 2. I've got no throughput benefits, no latency benefits, and no storage increases, but I've got brilliant high levels of availability. Now let's talk about RAID 5. RAID 5 is really the best of both worlds. You can't do it on AWS because the storage is so slow, they won't let you. RAID 5 gives you speed and redundancy. RAID 5 is considered striping with parity. And it's high speed and it's highly redundant. It's used by 99% of all enterprises, some form of RAID 50, RAID 60, or even RAID 5. What does this look like? Here you go. We've got our block. Let's say we split it amongst 4 drives. If we've got 4 4-terabyte drives, we get 12 terabytes of total capacity, because what's going on is as follows. We lose 1 drive to redundancy data. So here we go. In this environment, we basically copy block 1 to drive 1, block 2 to drive 2, block 3 to drive 3, and we put backup or parity data on drive 4. The next time we write our data to block 1 on hard drive 1, block 2 on hard drive 2. Now we put our backup data on hard drive 3 here, and then we store data on hard drive 4. Now the next time, for example, we put our data on drive 1, backup data in drive 2, data on drive 3, data on drive 4, and so much and so forth. So, kind of keep that in the back of your mind. RAID 5, speed and redundancy, but here's the problem with RAID 5. The act of writing this backup data, it can increase latency, and because we're dealing with block storage, which is so slow, guess what? Here's what we're dealing with. It's not even allowed on the AWS cloud. So, RAID 0 is fast and gives us everything we need, but redundancy. RAID 1 gives us all the redundancy in the world, but no speed. What if we blended them together? And that's RAID 10. So really, RAID 10 is a combination between RAID 0 and RAID 1, in which case we'll create a RAID array that's RAID 0 for speed, a backup RAID array for speed, and copy RAID array 1 to RAID array 2. Let's be fair. We lose RAID array 1. Guess what? We're good on RAID arrays 2, 3, 4, 5, 6, and everything else. So we're good on the other drives. So let's make sure we get this clearly. So I'll show you what it looks like. Here we've got 2 RAID arrays. The first case, we're combining RAID 0, 2 drives, back and forth, fast. RAID 0 on the other ones, that copies from RAID 0 array 1 to RAID 0 array 2. Anything happens with our first RAID array, don't worry about it. No big deal. We're good to go. Why are we good to go? We're going to be on the second RAID array. And that's why we're using RAID. I'm going to talk about a couple more file systems real quickly, and then I'm going to get involved in answering some questions. So let's talk about the next thing. We'll talk about the elastic file system. What are we talking about with regards to the elastic file system? Nothing special other than NFS file system, meaning if any of you have been using Linux or Unix storage environments for years, file storage, and you set up a network file system share, which was invented by Sun Microsystems 30 years ago, that's what we're talking about. That's the same thing that AWS Elastic File System is. It's the AWS branded, fully managed version of Linux Unix storage. That's it. And of course, with this, we have the same kind of versions like we do with any other kind of storage, where we've got the standard, which is the highest performance option, and frequent access, which is stuff where you're not going to access it frequently, but you have to pay for it when you retrieve it. We'll have our two options, which is burstable. Here's what burstable means. You've got access to this, but you can temporarily increase your speed, or guess what? Provision throughput, which is you say, I need this, and you pay for it ahead of time, and it's guaranteed to you. Again, no different than frame relay with a committed information rate and a burst rate from 25 years ago. Same kind of thing when we're talking about bursting. Now, what's good about is the Elastic File System is it's like NFS, right? So it's POSIX compatible, and it will work with your legacy systems. It's considered high throughput, high IOPS, low latency. One thing that I really love about the Elastic File System versus building your own file server, is it expands if needed. So normally, from an architecture perspective, you're planning how much storage you think you need 10 years from now, or 5 years from now, or 3 years from now, how long are you going to keep your systems? Then you usually double it, and you figure you got a good dose. I'm exaggerating the concept, but it's something like that. It's what's called a SWAG, a scientific wild something guess. Now here's where the cloud shines. The Elastic File System will grow on demand. So we'll automatically adjust size and capacity. I got to tell you, for the people that do capacity planning and systems administration, this is a huge, huge, huge thing. They'll be incredibly helpful. Here's what it looks like. We use the Elastic File System, so you can take your EC2 instances that are running Linux, for example, and mount them to an NFS SharePoint in a fully managed environment by AWS. Just like you would do in the data center, but here you don't have to manage it. Now, we talked about file services for Linux, right? So what do you think the next is? File services for Windows. Now, if you wanted to deal with file services for Windows, you could deal with a Samba share on a Linux system, or you could use Windows servers. Windows servers. So let's talk about Windows servers. When you're dealing with Windows servers, you're dealing with a fully managed, high availability Windows file system. Okay. Why is it? Because they're Windows servers that AWS manages for you. And because they're Windows servers, they use the server message block protocol, which means they're hosted on Windows servers. So because they're Windows servers offering Windows shares, you can get all those Windows system features like quotas and Active Directory. File systems for Windows also provides encryption in transit and in rest. What does this really look like? It looks like this. Basically speaking, you've got your server. You create your file system. You configure your file shares. You connect to your file shares, and that's it. You run your application. Simple, simple, and effective. While we're at it, let's get to the point where we talk about Amazon FSx for Lustre. So now let's say you needed a higher performance file system because block storage isn't good enough for you for some high performance computing. This is where we get into the Amazon FSx for Lustre, where you can get millions of IOPS and 100 gigs per second of throughput, bidirectional synchronization. And we can synchronize our data with multiple S3 buckets, for example, and this enables some truly high performance transfers via multiple threads. So Chris, at this point, I think what we should do is we should get to answering some questions. I don't want to leave anybody behind. I want to make sure that we can take care of everybody and everybody's got a good education today.
All right, give me just a few minutes. How long do you want to do questions for? Oh, I just realized what time it was.
10 to 15 minutes. I want everybody having a good experience. And even if it takes me 20 minutes, it's the end of the day. I'm okay with it.
Yeah. I might have to get people to drag out the hashtag save your voice mic if we go too long.
We don't want to do that. Well, I've got laryngitis, but despite having laryngitis, Despite having the doctors giving me on cortisone, I'm here to make sure that everybody gets an incredible cloud computing education completely free. EBS is network attached storage, Charles. Exactly, but network attached storage can be block storage, object storage, or file storage. It is, and that's the choice, is how the storage area networking is working, but it's definitely network attached storage. Apologies in its earlier. Will these videos be up for a few days to rewatch? Jason, I'm going to leave them on YouTube, and we're going to keep them there because I know a lot of people can't afford proper training, and I want everybody to be able to go through this 2 and 3 and 4 times, share it with their friends that need help. So we're going to leave it. We're going to leave it on our YouTube channel. We'll keep it for a while. Slightly unrelated question: how long is the discount code available for use? Chris, when does the discount code security for cybersecurity awareness month expire?
I'm glad. First of all, I'm glad that they're aware of it because we haven't even mentioned it. So that's nice. But that the discount code will be available through this weekend. So it will be available through Sunday. Sunday the 23rd. Sorry, I had to look at my calendar.
Charles, love this course so far. Is FXS the only available file service for Windows? Well, it's the only one that they do for you. But here's the reality. You can take any virtual machine in any cloud provider, and you can, if it's a Windows machine, you could just set up an NFS share. You can set up a server message block share, and poof, you've got your own Windows file system. You could take a Linux system and set up a Samba share and use that as a Windows file system. So that's the only one they manage for you. But you could do it the data center way, not worry about any managed service, and be good to go. So it's the only one that they manage for you. But in many cases, you don't want to have them manage for you. You want to be able to do it yourself, and then you'll be good to go. Chris, you can go to the next one. Mauricio, can we please whiteboard concepts and talk about them? Well, here's the thing. If we did it here, it would take too long and be a distraction. Plus, there's another reason we intentionally don't do this. 55, according to Harvard University, 55% of all communication is what you look like when you say something. 38% is what you sound like when you say something, and 7% from the actual content. If we hide behind slides like a certification provider would do, we would lose most of the communication skills that are necessary to make sure that our students actually learn. While it might work well for a subset of visual people, it doesn't work well for many people. For example, I can't learn that way. So we have to do things that are in accordance with what's best for the majority of the population. And that's why we intentionally do it this way, Mauricio. But in classes, we do that when we whiteboard our architectures. What is the storage attached to EC2 by default? Well, it depends. It can be instant storage or block storage. What do you want it to be? Instant storage goes away with system reboot, with system termination, and block storage does not. What kind of storage are you choosing based upon your business needs? Not default. Everything is, pretty much you're not going to use defaults for a lot of things. Your default VPC is not secure enough. What's the business requirements and what are you going to make it? That's what you need to think about. Good question, though. If we reboot the EC2 instance, is it possible to get the same instance storage for the same EC2? It depends if you terminate it or rebooted it. Generally speaking, if you reboot it, you're good to go. If you terminate the instance, it's lost. What is the max size of the instance storage? That's dependent upon the server itself. Most of the servers have 8 times 8 terabyte NVMe drives in them. If they're running RAID 5, which they usually are, that would give you 8 times 7, which is 56 total terabytes of storage in the entire server. But how much of that server is actually dedicated to other customers, and you don't know. So instance storage is going to be based upon the virtual machine and the cloud provider. And what you do with it, is it a dedicated server that you buy? Is it a standard server? So there's many factors that go into that. It's not a simple answer. Good question. Can I explain more information about proxy servers, Sunless? Absolutely. We'll be addressing proxy server type concepts when we talk about load balancers, and we're going to be spending a lot of time on load balancers, I promise you that. What's the difference between FSX and FSX for Lustre? Well, FSX is basically Windows storage. FSX for Lustre is high performance storage for big computing applications. Standard Windows file server and really slow, or are we dealing, or is FSX for Lustre is high performance file systems? Good question. Chris, we go to the next one. What's the difference between EBS block storage, EFS, which is basically Unix-based file storage, and FXS is basically a Windows version. So kind of keep that in the back of your mind. If you need a virtual hard drive for your system that's going to be accessed by one system, you're going to be using block storage. If you wanted to create a file sharing type of storage, where you shared it for 10 web servers to be using the same information at both times, you're going to need some type of file storage. If it's a Linux system, you're going to use EFS or NFS. And if it's a Windows system, you're going to use server message block, as well as server's message block for Windows, or Samba if you're using a Linux system.
All right, so we are now at the 3-hour mark. We're going to continue for 10 more minutes with questions. And then, of course, we'll be back again tonight for our Head in the Clouds show. And also tomorrow morning for a Cloud Career and Training Q&A session. So we'll do 10 more minutes worth of questions. And then we will be signing off at 3:10 Eastern Time.
Will the architect course cover the security aspect? It depends which architect course. If you're dealing with our Cloud Architect Career Development Program, we're going to teach you real enterprise-grade security, the kind of things that you need to do for the real world. If we're just looking at a course like this, like the AWS Certified Solution Architect Associate, or even the AWS Advanced Networking, we don't have time to cover security in this. I typically spend at least 50 hours with my students teaching security or more as they go through in our program. We talk about demilitarized zone design, all the non-native cloud security applications, which are really critical, how to integrate next generation firewalls and intrusion detection capabilities. You talk about writing security policies and determining what needs to be done. The encryption strategies, social engineering, anti-malware, how to lock down systems. That's not covered in any certification. Truthfully, it's barely covered in the CISSP, but our Cloud Architect Career Development Program covers it constantly. And that's why our students get cloud security architect jobs constantly. Like even Delroy Batt, who was a kid who came to us, no work experience in tech, just got his first cloud security architect job after training with us. And he had 0 cloud certifications, but he was competent as can be. But that's way beyond what's covered in, even with all 10 AWS certifications, there's basically no security worth talking about in them. So our architect course, yes, absolutely. Certified Solution Architect Associate, Professionals, Advanced Security, there's very little security in them. But we'll give you a lot more than we can do. What do you need to do after watching your course? Well, I don't know which job you want. And it's very different if you wanted to be a cloud architect versus a cloud engineer. As a cloud architect, I'm going to tell you right now, it's 50 to 80% business and 20% tech. So for the cloud architect, the first things you're going to need to know is the business piece. If you only learn tech, you'll never be a cloud architect, you'll be a cloud engineer. The business piece includes executive communication, executive presence, CXO relevancy training. What do you say to the CIO versus the CTO versus the CFO? It includes the emotional intelligence to build large teams. It involves sales training so you can help sell things. It involves learning how to build a business case and an ROI model to show the customer the value or solution is greater than its cost. It's going how you're going to be designing, present, and selling things. It's going to be teaching you how to negotiate large business deals. It's going to be about writing thought leadership documents, for example. Now, for the cloud architect or the solution architect, it's all about moving that stuff from the network and the data center. So it involves deep knowledge of understanding BGP, IP addressing, subnetting, and supernetting, software-defined networking, SASE, when to use a private line, when to use an Ethernet over MPLS private line, switching, VLANs, VLAN tagging, VLAN trunking, for example. It involves spanning tree, rapid spanning tree, channel, ether channel link aggregation groups, deep knowledge of DNS, DHCP, ARP, proxy, ARP, those kind of things. And then it involves deep virtualization knowledge and container orchestration knowledge, and deep knowledge of storage area and networking, and deep knowledge of databases and what kind of databases to use. And for example, but this is just for the architect, for example. And I don't know your career that you want, so I'm not going to. So there's that. But if you were an architect, it would be security, writing security policies, and what kind of anti-malware would be done. How did you lock down systems, for example? How do you design your demilitarized zone? What kind of next generation firewalls get included? What's your data loss prevention strategy that's going to be integrated? What's your security event monitoring system? So kind of keep that in the back of your mind. Those are architect skills, which are not covered in really certifications. So it depends on the career, but you didn't list the career, so I just gave you an example from the architect perspective. What makes a file system high performance, including the technology implementation? Well, it's really related to the throughput and the latency. Now, most of the throughput and latency things we're talking about on the cloud are relatively low performance. So what happens is, what do you need? And that's why it's involved in RAID. What stuff should be on the cloud? What stuff should be in a private cloud like a Nutanix cloud? What things can be in the public cloud? And that knowledge is based upon what the business requirements are. Because what somebody in a certification calls high performance could be totally low performance to somebody that needs high performance business requirements. So what is the business requirement telling you? And that determines whether it's going to be performant enough to absorb it or not survive it. As an AWS SAA, do you calculate or design and guide? I don't know what you mean by calculate, Charles. We design a solution, present that solution, and sell it back to the customer. Yes, I can always calculate storage capacity. That's easy. You just determine the size of the storage you want and determine what you're getting from your RAID array. That's nothing, but the key is what you need is based upon the business requirements. Is the security architect associate recommended for a specialization of someone in information security? Well, not really. I mean, if you want to do information security, what's recommended is to learn information security. Now, before you learn information security, you have to determine what kind of information security. Do you want to be on the ethical hacking side or the offensive security side? Well, that needs a very specific set of skills. Do you want to be on the defensive security side? Now, then you have to determine whether you want to be on the engineering and architecture side. If you're on the architecture side, how do you design the security, present it, and sell the security? If you're on the engineering side, how do you build the security? So that's really the key is, what kind of security do you want to do? But generally speaking, yes, it's good to know the data center or cloud technologies. The biggest problem I've ever seen in careers is people don't understand their career. Why doesn't everyone use multi-part uploads? They're supposed to. Some people just don't know to do so. Everyone should be using multi-part uploads for all files above 100 megabytes. Next one, Chris. What is a good entry-level job for a new SAA? What is the best certification that we can complete to get an entry level? Why don't you come in tonight? And tonight we're going to tell you what certifications can and can't do for your career. I'm going to tell you right now that a certification alone will not get anyone a cloud architect or a cloud engineer job. But I'm also going to tell you they're a valuable part of your total portfolio of what you can do. And they can be very useful in helping you get an interview. They can be useful in some ways to create the right brand if you have the right certifications, where the wrong certifications will hurt you. But then what it's really about is making sure you've got the skills to back it up. And tonight we will tell you all of what those skills are. So you'll know exactly what you need to become a certified solution architect or a solution architect for real and get hired or cloud hired like we do. And you'll know exactly the skills how to get hired as a cloud engineer. Both brilliant jobs, but they couldn't be any more different. They're about as different as an airplane pilot and a doctor. But I love them both, and they're magical. So let's do this. If you can give me a hashtag AWS Certified Solutions Architect Associate. And that way, everybody knows that you're here and having a good time. If you've not liked the content, please do so. And if you haven't subscribed and hit the bell, please do so you can we can bring you as much free training as possible. I'm going to rest my voice because I've had laryngitis and I'm working through it to make sure you all get cloud hired. If you've not downloaded the brand new free AWS Certified Solution Architect Associate and Professional book, please download it. The link is in the description below. And if you've not signed up for the free AWS Labs, I want you to get hands-on experience, but I didn't want to waste our time with things that we could easily do in a video. I wanted to make sure we could use this time to train you to build your best cloud computing career. So please sign up for that. And if you want to get your first cloud architect job or your first solution architect job, sign up for our Cloud Architect Career Development Program. And guess what? 30% off with this coupon code SECURITY in favor of Security Awareness Month. Have a great time. I look forward to seeing so many of you tonight. Take care, everybody. Let's get you all cloud hired.